So let me share my screen. Mm, So I'm sharing my entire window right now. And then, are you able to see my
Okay.
screen in the presentation mode?
Yeah, I'm seeing your screen. I will remove myself and leave your camera.
Sure. Can I go ahead and get started then?
Yes, can go ahead.
Awesome. Awesome. Hello, everyone. Thank you so much for taking your valid time for attending Malta Data Saturday. I know this is very special to me. This is a wonderful experience here today. You saw that grand welcome. I really thank Dennis for giving me this wonderful opportunity to be here on your platform. So thank you everyone for taking your time for attending the Data Saturday. So my name is Deepthi Goguri, and today we are going to talk about the method behind the magic of indexes in SQL Server. So this particular session is all about what happens behind the scenes at the data page level and at the index page level. So please be seated. Do not move here and there because all we are going to see is behind the scenes stuff. So if you move a little bit and come back again, you might not understand because this is at the page level, right? You will know what I mean in the coming slides. So yeah, let's get started. A little bit about me. You have seen the video, so I don't want to discuss about it again. But the most important thing on this slide is to look into my Twitter ID. If you would like to contact me or get in touch with me, it will be an honor. At DBA Nuggets is my user ID, and dbanuggets.com is my website. I do post all the internal stuff about SQL Server, and it's a very active website. If you wanted to know more about it, please visit. First of all, I would like to thank our sponsor Redgate for giving me this wonderful opportunity and for sponsoring for this wonderful event. Without your support, this event would not have been possible. So there are a lot of great tools with Redgate. Please go ahead and visit all the new upcoming news and like the tools which they are going to release. Thank you so much, Malta Data Saturday, one more time. And if you wanted to, sign up for their meetup, there are like wonderful session every month. So if you wanted to know about the SQL Server in deep, Azure, anything related to technology, please go ahead and sign up for the meetup group. So what are we going to discuss in this session today? We are going to dive deep into the query optimizer itself to see how the index actually work, how the data pages look like, how the index levels look like, how the intermediate levels, root level, and the leaf level pages look like behind the scenes. This particular session, we are not going to discuss about if the seek is better or the scan is better, but we are actually knowing how the data gets inserted at the page level, at the index page level, data page level. And whenever you insert any data into the table, how does that insert will also affect the uh, indexes, right? No matter how many indexes you have, how does that will actually affect? How does SQL Server have to update those indexes as well whenever you modify the data into the table? So we are also going to see this, how the SQL Server will use the indexes to get back the data as quickly as possible. So why should we even care about knowing the indexes, right? Let's talk about myself first. When I started my career, I used to read these books and like listen to the um, trainers how these actual indexes look like. But all the time I used to see those squares with the levels, but I never understood, until a couple of months ago, I never understood what exactly happens inside the page level as well as the index level. So once I came to know about it, I couldn't stop it. I wanted to share that information with as many people as possible across the world because this is like really interested stuff. Once you know about it, you will be very confident to, you will be able to understand, like, if I go ahead and add this index, what might be my performance benefits or what might degrade, right, in the performance. As a DBA and developers, we always have these questions like, how many indexes should I add on the table? Or should I create an index by including all the columns in the index? Or should I create an index especially on single columns, right? By adding a single column. And we do not know how many exactly we have to add to get those performance boost, right, for your queries. And whenever you run a query and see that actual execution plan on, and when you see the actual execution plan, you see those beautiful recommendations popping up with green color saying that if you go ahead and just execute this recommended index, you will see 95% of performance boost. But if you directly go ahead and execute the entire statement, right, by what it is suggesting, do you think it will be a real boost to your SQL Server or will it degrade? It might not be a good idea because what SQL Server might be telling you exactly is just go ahead and add that little column which is actually missing in your existing index to make sure you get that performance boost what I'm talking about. That's what it might be telling. But if you directly go ahead and execute that, you might be actually duplicating the index and you might be actually degrading the performance, thinking you might be improving the performance. It might go in the reverse way. So, by the end of this session, you will be able to understand all of these questions once you know the internals of indexes. So from now on, you are not going to see any of these, any of the wordings in my slides, but all you are going to see is these pages. The data pages or the index pages inside the SQL Server look like this. The picture which you are seeing right now on the screen is how they look like. So any data we are going to insert or update inside the SQL Server, they are always going to go to the 8KB data pages. This is how the data pages and index pages look like. Each page have 8 KB in size and each page have three different parts in it. Header information, where you'll find the metadata about the page itself, like page number, previous page number, next page number. Now you might be asking me why previous and the next page number, right? Because SQL Server have to know if at all, for example, it is scanning the entire table, it have to know where to go to the next page, right? So those are the pointer information at the header information of the page. And there will be a couple of more metadata information as well. When you see the intermediate level of the page, you see that 1 to 12 boxes, right? Those are the slots where the actual data, actual column data gets stored. That's called the payload area of the page where the data gets stored. When you see the bottom of the page, those little boxes are known as row offset array, meaning each box contain a pointer where the actual data of the row gets stored inside the payload area. Whenever SQL Server is searching on a row, then it have to definitely come to the payload area pointer where it have to come to the row offset array pointer, pointing back to the exact space where that data gets stored inside the payload area. That's how SQL Server have to do. SQL Server can't directly go to the payload area where the actual data gets stored. It will have to first go to the row offset array pointer. Here at the payload area, we mentioned 12 slots, right? That doesn't mean that we will only have 12 slots, but for our easy understanding and for our demonstration purposes, we took only 12 slides. That's the reason, like, it will be easy for you to easily understand what goes at the data page level. And when you see on the right side, top corner of the page, you see those two little symbols, right? The square represents the data page and the purple with a down mark arrow, right? It represents the index page. So why I mentioned these to represents the data page and the index page, like in the middle of our presentation, if you get confused in between and if you think what is she even talking about, I'm not even understanding, then I'm talking about the page. You can go ahead and look at the page number. Mostly I will be representing the page number, previous page number, next page number, and about the page itself. If you get confused, just go ahead and look at those symbols. The light blue in color is the data page and the purple represents the index page. So let's go ahead and create the brand new table, flowers. Now, why I mention flowers? Because I'm a woman, I love flowers. All women love flowers. And men should love flowers, right? Because they have to give to women. So, this table doesn't make any sense whatsoever, right? But it will serve the purpose of the demo. You will be able to understand what goes behind the scenes. So we are going to create the table name flowers with ID, flower name, owner, code, and the entry date for that particular table. Entry date meaning we are going to insert the data today, right now itself, but they will have the different dates just to make sure like it will serve our purpose again for the demo. So this particular table is actually a heap table. It doesn't have any clustered index on the top of the heap table. But then, even though if it is a heap table, we can directly go ahead and create a non-clustered index on the top of the heap table. So let's go ahead and talk about the non-clustered index first, and then later down the session, we will go ahead and create the clustered index so that you can easily differentiate how they both actually look like. So let's go ahead and create unique index, the non-clustered index, name owner on flowers, which is on the key columns flower name, comma owner. So whenever we create any table, SQL Server will go ahead and allocate that unallocated page from the disk to the table, and from the table, it have to grab into the memory, which is a buffer pool, to do the operations over there. Just remember that SQL Server directly cannot modify the data at the file level inside the disk subsystem. It cannot touch the MDF file directly and insert the data over there. All the pages have to grab into the buffer pool, do the modification over there on those 8 KB pages. Once they are dirty with the written data, then the checkpoint process will actually kick in every minute by the SQL Server automatically to flush these data, these dirty pages out of the buffer pool and harden them onto the database file system. That's the exact process. So so here we SQL Server will also go ahead and allocate a page to the data page itself. And as we created the index, it will also go ahead and allocate a page to the index as well. So let's say that the data page number is page number 11 and index page is page number 12. But when you see here, the data page, it represents 1 is to 11, right? So what is that one? One represents the file name, the database file name, which is the MDF file, right? So index page is also on the primary file, which is the MDF file, and the index page is page number 12. Before beginning, let me tell you this. For our demonstration purposes, we have very little buffer pool where we can only fit 24 KB size. You might be saying, what? Right? With the 24 KB, you can't even start the SQL Server. But then we can be able to easily understand down at the page level what's going on. If I put 1 GB there, then my buffer pool can be able to fit in some 1,000 pages, and you might not even see what I am even talking about because I can't fit 1,000 pages on my screen, right? So for our easy demonstration purposes, we are only fitting three three pages, both index page as well as the data page. Entire memory we have buffer pool is 24 KB, meaning we can only fit 3 pages. And you might be asking me, what if we need more pages while we are inserting the data? We might be creating new pages, right? How does those pages fit into the memory if we can only fit in 3 pages? How does the activity goes around, right? Just like the real-time scenario, how SQL Server will actually, whenever there is a memory pressure on the buffer pool, SQL Server will actually evict least recently used pages out of the cache first. So that is the exact same thing is going on here in our presentation as well. So that's the point I wanted to mention even before entering the data into the table. So let's get started. Let's go ahead and insert the first record into the flowers table with the flower name Acacia and owner name Best. So here, as I said, SQL Server will first allocate one single data page and one single index page, right? And you can see those indicators on the top of the page. So here we have the brand new page. So let's go ahead and insert that particular record into the data page. Now the Acacia best record has been entered into the page number 11. But if you see that payload area, the first slot represents 30 comma 5 zeros. You might be saying, what is that exact number, right? The first 30 represents the size of the record itself, and the 5 zeros after the comma represents the bitmap. So, what is this bitmap? If there is a value for the column, right, that bitmap value will be 0. Like there are 5 zeros and there are 5 columns. Each zero represents each column value. If there is a value, that particular bitmap of that zero will be 0. And if that particular column value has a null value, then SQL Server do not want to store the null value at the payload area, but instead it will manage those nullable values in the bitmap itself by turning that that particular column 0 into 1. We are going to see some of the inserts with the null value, and at that time you will be understanding how SQL Server will actually manage at the page level. Now you might be saying, what will happen? Null value gets stored inside the payload area. That's the least way how SQL Server can actually save the space at the page level by turning those zeros into ones, and without saving those nullable values, it can directly go ahead and manage those nulls by changing the bitmap. That's the beauty of the SQL Server, right? At the page level. So when you look at the bottom of the page, page number 11, you see that first slot, the slot array, is pointing to the 1, right? That meaning it is directly pointing out to the slot number at the payload area where that first record got stored. That's how SQL Server will read it. And whenever we insert any values into the page level, we have to also manage the index, right? Because our index is on the top of the flower name, comma owner. Those two are the key columns of the index. SQL Server will have to manage the index as well by inserting those values into the index page as well. So let's go ahead and insert Acacia Best. Only those two columns get entered into the index page because that's where our index is, right? We created only on those two columns. So that's the reason only two columns gets inserted at the index page. So let's go ahead and do that. And if you see the first slot represents 6, 0, 6 represents the size of the record itself inside the index page, and 00 represents the values, Acacia and best. For example, if the best is null value, then it will be 0, 1. That's how the SQL Server will manage the nulls, right? But if you see here, 1 is to 11 is to 1. So this is the actual pointer pointing back to the data page. If you're searching on like select star from flowers where flower name is Acacia, then first SQL Server have to go here. Like if it uses index, right? We do not know if it can use index or if it doesn't use index. But if it uses index, as we are asking select star from, if it uses the index, it have to grab the additional columns from the data page because our index only have the Acacia best. The other columns it have to grab from the data page. Now, how does that pointer actually look like? It looks like this. The pointer is pointing back to the data page, page number 11, and it is pointing to the first slot, which is pointing to the first slot inside the payload area. That's how SQL Server will read it. Let's go ahead and insert one more record into the table with flower name Erica and owner Newton. Since we have space on the page number 11, the data page, let's go ahead and insert that particular record into the page number 11. When you observe here at the row offset array, those pointers will be also updating. And how do SQL Server read those pointers? From right side to the left side. And we do have space inside the index page. We also have to manage the index, right? So let's insert Erica Newton into the index page as well. Let's go ahead and insert Daisy stamp record into the flowers. Do we have space on the page number 11? No, right? So SQL Server will go ahead and allocate a unallocated page from the disk to the table, but then we have to grab that page to do the insert, right? So it have to be grabbed into the buffer pool. So here it is, it has been grabbed. SQL Server will give the page number 13, and the previous page number, if you observe on the page number 13, the pointers should be updated first. So the previous pointer is pointing to the page number 11 because that's the data page, right? And on the page number 11, the next page will be updated to page number 13. So now we do have space. So let's insert Daisy stamp into the data page. As we inserted the record over the data page, we have to also manage the index page, right? Let's go ahead and insert Daisy stamp into the page number 12, the index page. But if you observe something here, we just inserted Daisy stamp. Daisy starts with D. And if you see the first record that has been entered in the page number 12, the index page, the first record is Acacia, the flower name, and the second record has the flower name Erica. And we just insert Daisy stamp. Daisy starts with D. So physically, it has to actually stored in between Acacia and the Erica, right? But SQL Server doesn't have any way to physically modify the data at the page level. So that is the reason it will go ahead and somehow it have to manage it logically at least, because that's where the SQL Server will be pointing to grab the data, right? So it will go ahead and modify the data at the payload area into the order of the key columns of the index. So first, Acacia should come. So that is the reason the first slot is pointing to the first slot of the payload area. When you see the second slot at the row offset array, it is pointing to the ninth slot. So the ninth slot is Daisy. So you understood, right? The third slot is pointing to the fifth row, fifth slot is pointing to Erica. So because it cannot physically modify the data inside the page itself, it will be actually modifying the data at the payload area logically, such that SQL Server, whenever we do the selects, it can actually grab the data in the order of the key columns of the index somehow, because we modified the data at the payload at the row offset array. That's how it will manage actually. This is how the data pages look like, left side your screen. And if you see those two pages, they are interlinked between each other with the double-sided arrow. Those double-sided arrows represents they have the pointers pointing back to each other. They are interlinked, right? When you see the index page, it's still just one page, 12, but that's going to change drastically in the coming slides. Let's go ahead and insert Gardenia Golf into the table. Now, do we have space on the page number 13? Yes, we do. So let's go ahead and insert Gardenia Golf. And then as we inserted the data into the data page, we should also insert that particular record into the index, right? But do we have space on the page number 12? No, right? So what SQL Server will do is just like how it will allocate a page to the data page, it will also allocate a page to the index page. But there is something different going on here. Since the indexes are the B-tree structures, as we are adding a new page for the index page, there should be also another page allocated as the root page of the index. Because as you know, the indexes are the B-tree structures. If you are keeping on adding the pages, there should be another page which will actually have the pointers pointing back to these two pages. These two pages will be the leaf level of the index. So as we are unable to insert a new record over here, a brand new page get created, and page number 12 and that brand new page will be the leaf level of the index, and there will be one more page which will be created as the root level of the index. So let's go ahead and evict because we cannot fit in any pages here. Now we have to grab two new index pages, one for the leaf level and one for the root level page. So as we cannot fit in, let's go ahead and evict the least recently used pages, page number 11 and page number 13, so that we can fit in brand new two index pages. The page number 14 will be the leaf level page number 15 will be the root level page. But as we add it, we have to update the pointers on page number 14, right? Because page number 14 is a leaf level page, it have to be interlinked between the a previous leaf level page, which is 12. So the previous page will be pointing to page number 12. Next page on page number 12 will be pointing to page number 14. So we do have space on page number 14. So let's insert Gardenia Golf over there. But as we inserted the data now into the page number 14, we should also have those pointers on the root page pointing back to these two leaf level pages, page number 12 and page number 14. So let's go ahead and insert those pointers in page number 15, which is the root page. How do SQL Server read that? Any flower name which is equal to acacia and less than gardenia will go to the page number 12. Any flower name which is equal to gardenia and greater than gardenia will go to the page number 14. That's how SQL Server will read it. Now, this is how our index pages look like. Previously, we just had one index page, which is page number 12, but we have actually keep inserting the data. So it cannot fit in the data into the page. So SQL Server actually created another page for the index, which is page number 14. Page number 12 and page number 14 will become the leaf level pages. And there should be another page which got created, right? Which is page number 15, having the pointers pointing back to page number 12 and page number 14. Data pages, if you see, they are still the same, but that is going to change in the coming slides. Now let's go ahead and do our first select star from flowers where flower name is Erica. How do you think SQL Server will process this query? Think for a minute. As in the where clause, right? In the where clause, we are having that particular key column, which is already in the index because our key columns are flower name, comma, owner. And we are taking here in the where clause, we have the predicate. We are searching on the flower name, right? So think it will be using the index. But then we are asking for select star from. We don't know what SQL Server will intelligently decide that for us. So let's go ahead and see. As we have 3 index pages, right? But 2 data pages. If SQL Server will decide to use the index, first it will have to access the root page of the index because SQL Server directly cannot go ahead and look into the leaf level pages because it doesn't know where the Erica is yet. So it have to go ahead and access the root level first. So think it will go to the page number 15 and Erica is actually pointing to page number 12. Let's say page number 12, it will directly go to the row offset array pointer, pointing back to the data exactly which is stored at the payload area of that page, page number 12. Get that pointer, that is actually pointing to the data page. Let's say it is pointing to the page number 11, slot number 1, right? So it will have to go to the page number 11, data page number 11, and slot number 1 and grab that information from there because we are asking for select star from. It have to go to the data page, right? So how many page reads does the SQL Server have to do to process this query? Root page, page number 15, leaf page number 12, and then the data page number 11 to get that one record, right? If it uses the index, which is 3 page read. But instead, SQL Server will think, why should I even go ahead and use the index? Why not I scan the entire table? Because we just have 2 pages in it. So let me go ahead and scan the entire table because that is easy for me. That is less, it takes less processing and less resources for me to do that particular scan. So let me go ahead and do that. So what did we understood from this slide until now? Scans doesn't mean that it is always bad. And seeks doesn't mean it is always good. You have to just go ahead and see why SQL Server choose the scan instead of using the index, right? There might be less number of pages for the table. That might be the reason it choose. So next time, if your interviewer, if you're going for an interview, if they ask you what are you going to look for the performance thing in your execution plans, please do not say that it's because of scans, right? Tell them that I will look into the scans of why it choose to do the scan instead of using the index, right? So SQL Server here decided to do the scan. So which page does it have to access first? Page number 11 and then page number 13, because it have to scan the entire table. Page number 11 not in the memory, so evict page number 12, grab the page number 11 into the memory. It will scan the entire page. While it's scanning, it found the Erica, but then it do not know if there is another Erica on the next page, page number 13. So it will go ahead and evict page number 14, grab page number 15, scan the entire page. That's how SQL Server will intelligently do the scan instead of reading so many pages. Let's go ahead and insert Bergenia Wade record into the table. Now, do we have space here on page number 13? No. So SQL Server will go ahead and allocate another page, but that page will come into the memory. So let's go ahead and evict page number 15, least recently used page. Page number 16 is in the memory, and the previous page number should be updated, page number 13. Next page on page number 13 will be updated to page number 16. We do have the brand new page, so let's insert Bergenia Wade into the data page. But as we actually inserted the data page, let's go ahead and also insert and manage the index as well. Do we have space? No, right? So let's go ahead and evict page number 11 and get that page number 15. Now, why page number 15? Why not directly the leaf level pages? As I said, SQL Server have no idea where to fit in this particular Bergenia Wade into the leaf level of the index. Definitely, it have to access the root page to know where that root page is pointing to which page at the leaf level it is pointing to. So SQL Server, it has set the root page of the index has set to go to the page number 12. So because it start with the Bergenia Wade, it have to go to the page number 12, no other go. So does the page number 12 is in the memory? No, right? So let's go ahead and evict page number 13 and get that page number 12. But if you observe here, page number 12 is completely full. So how SQL Server will do this? How does Bergenia Wade will fit into this particular page? There is something known as page split process is going to happen here, which is very interesting, meaning it will actually create a brand new page for the index, but then half of the data from the page number 12 will be actually moved to that new page. You might be saying, why is that thing going on? Like why it should have to move half of the data from page number 12 to the page number to the new page number, right? Why can't this Bergenia directly go to the page number, brand new page number? No, it cannot go because root page is actually saying Bergenia Wade has to go to the page number 12. So in order to get the space on page number 12, half of the data have to move from page number 12 to that brand new page such that it can have some space to fit in Bergenia Wade onto the page number 12. So let's go ahead and see this in action. So do we have space to fit in a brand new page? No, right? So let's go ahead and evict page number 16, grab page number, give it a page number 17. Previous page number will be updated, which is page number 12. So the other thing we have to remember is whenever the page split happens, right? That page will be actually created just after the page number. So as we split the page number 12, a brand new page got created just after the page number 12, which is page number 70. That's the new page. But then previously, do you remember we have actually two leaf level pages, which is page number 12 and page number 14. So as the page split happened, the page number 17 will actually fit in between page number 12 and page number 14. So now we have three pages in the leaf level. So now we have to remodify those pointers, right? Because we have previously page number 12 and page number 14. But as we fit in this particular page number 17, just in middle of these two pages, the pointers have to be pointing back and forth, should be also modified, right? So on the page number 17, the next page will be page number 14, right? Because this is the middle page. So we do have space here. So half of the data from the page number 12 will be moved to page number 17. So this particular highlighted maroon color data will be actually moved to page number 17. We do have space right now on page number 12. So Bergania will fit in on page number 12. But then page number 12, on page number 12, if you observe, the pointer is actually still pointing to the page number 14, the next page. If you observe the page number 12, the next page is pointing to page number 14. So that should be updated, right? So which page should it update to? Because the very next page is the brand new page, page number 17. It should update to the page number 17. But then there is another page where we have to also update the pointer. Do you know which page it is? That's the page number 14, because that's the next page, right? Page number 14, not in the memory. Evict page number 15, page number 14 in the memory. And if you see the previous page on page number 14, it is pointing to page number 12. It should not be page number 12. It should be page number 17, right? So that's the previous page. Let's update that. And then as we added a brand new page, because page split happened and a brand new page got created, page number 17, we just can't leave that like that, right? Like that page cannot hanging there without any connection to the root page. So there should be a pointer at the root page pointing back to the page number 17, which is brandly new created. It should have the pointer pointing back to this new page, right? So SQL Server have to update a pointer information onto which page? Yes, page number 15, which is the root page. Page number 15, not in the memory. Epic page number 17. Page number 15 in the memory. Let's go ahead and update the pointer pointing back to page number 17. So it is pointing back to right now. All the connections are perfect. If you observe the index pages here, previously we just had two pages, the leaf level pages, page number 12 and page number 14. But since we tried to insert Bergenia Wade onto page number 12, because the root page was showing it have to fit in on page number 12, but the page is full, page number 12. So a page split happened, a brand new page got created, page number 17. Half of the data from page number 12 has moved to page number 17 so that Bergenia Wade can fit into page number 12. But then page number 17 can't hanging there without any connection to the root page, right? So the pointer has actually been pointed back to the leaf level page, page number 17. So it has been updated on the root page, page number 15. We still have page number, 3 page numbers, data page numbers, and 4 index page numbers. Let's go ahead and insert Kalmia Morris record into the table. So do we have the data page over here? No. So we have to grab the data page where we can insert this particular record. Let's evict page number 12, which is the index page. Grab page number 16, which is right side your screen. Do we have space? Yes, we do. So let's go ahead and insert Kalmia Morris. So as we inserted Kalmia Morris record into the data page, we should also maintain the index. So let's go ahead and see where this Kalmia have to fit in or into the leaf level of the index. So which page do we have to access first? That's the root page, right? Page number 15 is showing that this particular Kalmia have to fit in on page number 14. Page number 14, very luckily, it's already in the memory. So let's go ahead and fit in Kalmia Morris into the page number 14. Sometimes it's easy to insert the data as well as to update the data into the index when we have all these pages inside the memory. Now let's go ahead and see how these two things will get processed. Can you observe these statements for a little bit of time if you find any difference? There is no difference, right? Just that order of the where clause has changed. So SQL Server have that way, right? It can easily remodify the order of the, inside the where clause. If you change the order, it can easily remodify the order in the order of the key column of the index. So our key columns are in the order of flower name, comma, owner. So for the second statement, SQL Server will just go ahead and remodify the order as select star from flowers, where flower name is Kalmia and owner is Morris. So, how do you think SQL Server will process this? Since we are asking inside the where clause in the key column of an index, like in the order of the key column of an index, we are asking in the where clause for the flower name and the owner name. It will definitely use the index because our index is on these two columns, right? But then we are asking for select star. What does that mean? That means that SQL Server have to access the data pages, right? So let's go ahead and see how SQL Server will use the index to do this. So on page number 15, it's pointing to page number 14. Page number 14, it is pointing to data page number 16, slot number 2. Page number 16, right side your screen, it's already in the memory. So it is pointing to the slot number 2. Slot number 2 at the bottom of the payload, at the bottom of the slot array, the second slot is pointing to the seventh slot inside the payload area. Seventh slot have here the Kalmia Morris. That's how SQL Server will actually use the index to grab the results as quickly as possible. Let's go ahead and insert a different record this time where the date of entry has null value. Now, do we have space here? On page number 16, data page, we do not have, right? So SQL Server have to create a brand new page, grab into the memory by evicting page number 15. Brand new page, got the page number 18. Previous page number should be updated, page number 16. Next page on page number 16 should be updated to page number 18. So since this is a brand new page, let's go ahead and insert funnel Hibbert. But did you observe the sixth slot of the payload area? It's actually empty. Now, why is it empty? As I said, there is that beautiful thing that SQL Server can do at the page level is to save the space inside the payload area by saving those nullable values, right? It won't save the null values at the page, but it will just go ahead and update that bitmap value directly. So the sixth slot, like the fifth column, right? The fifth column is having null value. So it will directly go ahead and change that particular column value from 0 to 1 because it is a null value. So as we inserted this particular record, we should also maintain the index. So which page we have to access first? Yes, that's the root page. Page number 15. Page number 14, not 15 is not in the memory. Let's evict page number 14, grab page number 15. It is showing to go to the page number 17. Page number 17 is the leaf level of the index. Page number 17 not in the memory. Evict page number 16. Page number 17 in the memory. Do we have space here? Yes, we do. So let's go ahead and insert funnel Hibbert into the index. Now we have 4 data pages. We just added 1 data page and we still have 4 index pages. Let's go ahead and do this. Select star from flowers where flower name is Kalmia and owner is Morris. How do you think SQL Server will process this query? You know, it will definitely use the index, but then we are asking select star again, and then as the index is in the key column order of the flower name, comma owner, first SQL Server have to go ahead and search for the flower name Kalmia, and then later Morris, the owner. So which page do we have to access first? Yes, that's the root page, root page 15. 15 is pointing to page number 14. Page number 14 not in the memory. Evict page number 18. 14 in the memory, right side your screen. So the page number 14 is pointing to page number 16, slot number 2. Page number 16 not in the memory. Evict page number 17. Right now, page number 16 is right side your screen. It is pointing to slot number 2. Slot number 2 is pointing to the seventh slot in the payload area, right? It is Kalmia Morris. That's how SQL Server will actually use the index to process this query. But this time we are asking a little bit different. Select star from flowers where owner is Morris and flower name is less than or equal to Kalmia. As SQL Server have to access in the key column of the index, in the order of the key column of the index, the first column inside the index is on flower name, right? So it have to first go ahead and search for the flowers which are less than or equal to Kalmia. Do you remember the last entry into the data page is with flower name Kalmia? That means all the pages it have to access, all the pages. So let's go ahead and see.
Hello, Lepti. There
Yeah,
are some questions from YouTube. Would you like to take them now or on the end?
can we do that end?
At the end. Okay, great.
Thank you. So right now we have 4 data pages and 4 index pages, right? So sorry, I missed something here. So we have to actually search all the flower names which are less than or equal to Kalmia. So let's think SQL Server will actually use the index. That means it will have to access the page number 15. First, page number 15 it have to access, and then it have to search for each and every page for the Kalmia. That means it have to go and process each and every step at the leaf level of the pages. So let's say it will first access page number 12. At the page number 12, it will directly go to the payload area, like the slot area, right? Where it is actually pointing to the record. And from there, it will grab the page number and slot number of the data page, go back to the data page. Let's say it is accessing page number 11, which is the data page. Then grab that record information, come back to the index, and get that second slot from the from the row offset array of page number 12, which is again the leaf level of the index, and then go back again to the data page, grab that page. It will go back and forth, back and forth, back and forth. It will have to do at least some hundreds of page rates to process this particular query. So instead of that, what SQL Server will do is let me go ahead and directly scan the entire table, all the pages. Like we just have 4 data pages, right? So let me go ahead and scan the entire table instead of doing these many hundred reads. So first it will have to access page number 11 and it have to read all of these pages. So right now page number 11 not in the memory, evict page number 15, page number 11 in the memory. It will go ahead and scan the entire page. The next page it have to access is page number 13, not in the memory. Right now, page number 13 in the memory, it will scan the entire page. Next page, page number 16, right side your screen, it will scan the entire page. The next page is page number 18. Page number 18, not in the memory. Evict page number 11, get page number 18. While it's been scanning, it will find the record Kalmia Morris at the page number 16. Right now, let's go ahead and insert one more record into the table, hibiscus. Do we have space? Yes, we do. So let's go ahead and insert hibiscus Roberts into the page number 18. So as we inserted, we should also maintain the index, right? So which page do we have to access? Yes, that's the root page, page number 8, page number 15. Page number 15 not in the memory, evict page number 13, page number 15 in the memory. So it is pointing to page number 14. Page number 14 is the leaf level of the index. Page number 14 not in the memory, evict page number 16, page number 14 in the memory. So do we have space? Yes, we do. So insert hibiscus Roberts here. Right now we have 4 data pages and 4 index pages. Let's insert one more record, Carnation Preston. Do we have space on the page number 18, right side your screen? No, we don't, right? We just have that one slot of empty space where we cannot fit in the page. Usually in our demo, it's just one slot at the payload area. That one slot is saved by the SQL Server. But in real time scenarios, you might be having so many null values. It can actually fit in a couple of more records into the data page, might be, right? Um, so we don't have space here to fit in that particular record. So let's go ahead and grab a brand new page from the disk to the table, from the table to the memory. Evict page number 15 to fit in the brand new page. Give it a page number 19. Previous page number should be updated, page number 18. Next page number 19 on page number 18. And then insert the Carnation Preston here. As we insert it, we should also update the index, right? So let's epic page number 14. Check where the Carnation have to go at the data page level, like at the index page level, the leaf level page. It is actually pointing to page number 12. Page number 12, not in the memory. So let's epic page number 18. Page number 12 in the memory. So let's go ahead and insert Carnation Preston here again. Right now we have 5 data pages and 4 index pages. Let's go ahead and see how SQL Server will actually process this query. Select flower name, owner from flowers, order by flower name, owner. This is very easy to SQL Server, right? Because it's asking for only flower name, owner and order by flower name, owner. We do not even have to mention order by because we are directly accessing those 2 key columns and they are already ordered, right? But as we are asking for only flower name, owner, SQL Server doesn't even have to go and touch those data pages, which is beautiful, right? It can directly go ahead and get all those information from the leaf level of the index itself. So as we are asking for every flower name and owner name, it will directly go ahead and scan the entire index. It will directly go ahead and access those leaf level pages. So which page do we have to access? It will go ahead and get that page number 15, scan the entire page, and then it will have to go to the next page, the index page, which is page number 12, scan the entire page. Next page is page number 17, evict page number 19 to get that page number 17, scan the entire page, which is the leaf levels of the index, right? And then the next page is page number 14. Page number 14 not in the memory, and then it will scan the entire page to get that all the information, right? It will just go ahead and scan the entire index to get that information. Let's go ahead and insert Jasmine Acosta into the table. Right now we have 5 data pages and 4 index pages. So we have to insert one more record into the table, which is Jasmine. So we do not have any data page here. So let's evict page number 12. Grab page number 19, right side your screen. We do have space, so let's fit in Jasmine Acosta. But then we have to also insert the record into the index as well, maintain the index, right? Evict page number 17. Which page do we have to access first? Yes, that's page number 15. Page number 15 is showing that it have to go to the page number 14. But then page number 14, left side your screen, it's already inside the memory. But then do we have space to fit in? No, right? So again, the page split happens here and then a brand new page gets created. Let's see how that will happen. Evict page number 19 to get that brand new page with a page number 20. And then the previous page number should be updated to page number 14. The next page on page number 14 will be updated to page number 20. As we have space here, let's go ahead and we have space, but then this is a page split, right? So half of the data from the page number 14 should be moved again. And then the hibiscus is actually fitting onto the page number 14. And then there is something else here because we actually created the page number 20, right? The brand new page, it just can't hanging in there without the connection to the root level page. So where we have to update that pointer information onto the root page, right? But our root page, which is page number 15, is actually full. That means again the page split happens to the page number 15, meaning a brand new page gets created, right? So let's go ahead and see how that will happen. Evict page number 14, brand new page gets created, give it a page number 21. Previous page number will be updated to page number 15. Next page on page number 15 will be updated to page number 21. Half of the data will be moved to the page number 21. But then if you observe the brand new page number 21 got created. So we have to have a page, the root page, that will be actually pointing back to these two pages, right? Because page number 15 is no more the root page anymore because we have actually split. So there should be a brand new page that gets created to actually have the pointer information pointing to page number 15 and page number 21, which then these two pages will become the intermediate pages of the index. So right now we have to have a pointer pointing back to page number 21, which will be the intermediate page. So we have to have a new root page. Every page number 20, get that brand new page, give it a page number 22. That will be the actual root page right now. Page number 15, it's gone. It's no more root page. That will become the intermediate page. And then on page number 22, the pointer information will be updated. So how does this look like? This looks like this. Right side your screen, if you observe the leaf level pages, previously we had only 3 pages, page number 12, 17, and 14. But then we tried to insert a record into the page number 14. Page number 14 is completely full. So there was a page split happen. Um, so there was a page split happen. Half of the data moved to page number 20. But then page number 20 just can't hanging in there. We have to update a pointer pointing back to page number 15. So page number 15 is completely full. So we had a page split again, where then a brand new page got created, which is page number 21. And then a pointer information is pointed back to page number 20. As page number 15 and is no more root page, we still have to have a root page, right, to the index. So a brand new page got created, which is page number 22, pointing back to these two intermediate pages, which are page number 15 and page number 21. But then if you see the data pages, we have 5 data pages. Now this is our last select that we are going to do, and then we are going to see the clustered index, how it actually look like. Now select owner from flowers, where flower name is Jasmine and ID is 5. How do you think SQL Server will process this query? Because we have the index in the order of flower name comma owner, and we are just asking for owner, right? Select owner from flowers. So SQL Server will access the index because in the where clause we asked for flower name. Flower name is the first key column of the index, and then we are also asking for ID is equal to 5. Do we have the ID inside the index? No, right? So for finding this particular record, SQL Server have to access the data page where that ID file is stored. So first, as it access the root page, which page do we have to access first? No, that's not page number 15. Page number 15 is no more our root page. Page number 22 is our current root page. So it will access the page number 22. It is pointing to the intermediate page, page number 21. Page number 21 showing it is actually pointing to the leaf level page, page number 20. Page number 20, not in the memory. Grab the page number 20 into the memory. So do we have here Jasmine Acosta is actually pointing to data page, page number 19, slot number 2. Page number 19, luckily inside the memory on your left side, it is actually pointing to slot number 2. Slot number 2 pointing to the 7th slot, right? Where Jasmine Acosta is there. But then we are asking for ID number 5. But we do have ID number 10. Now, why SQL Server has to go to the data page? Because we are asking for where ID is 5 as well, right? So as ID is not in the key column of an index, it have to go to the data page to find that information. But then as we do not have ID number 5, it won't return us any result. It have to process all these steps to find nothing, right? But then until now, we have only non-clustered index, but let's go ahead and create clustered index on the top of this heap table, right? We are creating it on the ID column. So what will happen once we create the index, clustered index? All of those data pages will be sorted out in the order of the ID column because that's where the clustered key is, right? We have created it on the ID column. So how does our intermediate pages and the root page of the clustered index look like? It looks like this. You might be thinking, oh my God, what are all these numbers, right? Let me explain it clear. Let's take the example of page number 23. Page number 23 and page number 24 will be the intermediate level of the clustered index. And right side your screen, page number 25 will be the root page of the clustered index. So how to read it? On page number 23, all it have is the ID column, the ID, and then a pointer pointing back to the data page itself. That's all it contains because we just have that clustered key on ID column, right? So page number 23 and page number 24 have those pointers with the ID column and a pointer pointing back to the data page itself in the sorted order, right, of the ID column. And then on the root page, page number 25, all it have is a ID column and a pointer pointing back to these intermediate pages. And how does our leaf level of the clustered index look like? Leaf level of the clustered index are actually the data pages itself in the sorted order of the ID column. If you see the data here, 1, 2 pages, all the pages, they are sorted out in the order of ID column 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10. These are all the data pages in the sorted order. But how does they actually look like, right? In the structure level, the clustered index is the left side your screen. How does that actually look like? All the leaf level pages of the clustered index, all these 5 pages, right, that we talked about all of our presentation, those are the actual data pages. SQL Server doesn't create any new pages for the leaf level pages, but then they are the actual data pages sorted out in the order of the ID column. And when you see the intermediate pages 23 and 24, they contain the ID column and a pointer pointing back to the data page where that ID is there. And in the root level of the index, page number 25, all it contains is ID and a intermediate page pointer. But then as we created the clustered index, how does our non-clustered index gets affected because of this clustered index? Nothing gets affected except the root level, except the leaf level of the non-clustered index will change a bit. How does that will change? Previously, the leaf level of the non-clustered index have that page pointer and a slot pointer, right? At the payload area, it have a pointer pointing back to the data page and the slot number on that data page. But then as we added the clustered index, it will, the leaf level of the non-clustered index, all it contains is the ID values which are pointing out to this clustered index. How does that look like? The leaf level pages of the non-clustered index. Once we add the clustered index, this is how the leaf level of the non-clustered index look like. If you observe the pages, the light blue in color are the ID column, ID values actually. Previously, they used to have that pointer pointing to the data page and the slot numbers of that particular record. But then now they will directly point having that ID column, right? It will directly have that ID value clustered key inside the leaf level of the non-clustered index. But then if you observe the 24, 21 page, intermediate page of the non-clustered index, they, they remain the same. They will directly pointing back to the leaf level of the non-clustered index. So in the summary, what we have discussed is we have dived deep into the query optimizer itself to know how the data pages and the index pages look like, how our inserts or updates to the data pages actually affect the indexes, how SQL Server have to take that extra step to modify and maintain these index. Now, just imagine if you have those duplicate indexes. Just think about how much time and resources SQL Server have to manage for maintaining all those duplicate indexes, right? Instead of getting that performance boost, you're actually decreasing the performance. So please make sure you do not have those duplicate indexes. Please do consolidate your indexes so that that particular indexes will be unique, and your optimizer will love to use those indexes for your queries for better performance. And we have also seen how SQL Server will use the indexes to get back the data as quickly as possible. And I would like to thank Dennis one more time for giving me this wonderful opportunity um, to present for Malta Data Saturday. I love this session and I love to present for Malta Data Saturday. Thank you.
Thank you. Thank you very much. The session was really great. A very deep review about the indexes. And we have on the YouTube, Giovanni Guarino made some questions during your session. Can you see
Mhm.
the questions on the comments? I'm
Let
not
me
I'm not sure if you can match the questions about the moment what you were talking at the moment.
see the comments. So, if I'm running out of time, I can take all the questions. I can email them. Um,
No, no, no problem. You have
oh,
time.
there are several. There's several of them.
Um,
So where should I
um,
start from?
no, no, Giovanni Guarino. Below the compliments, all these are were questions for you. I'm not sure exactly what point of the session he was
Yeah,
talking
yeah.
about.
After the okay, so complements and all movement in memory are transactions, right? Um, yeah, that will happen while the transaction is going on. That happens behind the scenes while our transaction is happening, moving the data from the data pages, from the memory stuff. This is really important to understand how it works. Sorry, no, no, this is SQL engine actually. Um, Thank you so much, Joseph, and thank you so much. Wonderful explanation. I studied it a lot. Thank you so much. I see more of these compliments, but I don't see much questions. Um,
Um,
yeah.
yeah,
You
traffic in
did you
memory
find?
handle the transactions, the questions about transactions, one comment about NoSQL, but
Yeah, this
not
is
sure if I got.
not about NoSQL. This is about SQL Server. If I go out
Yeah,
of SQL, I have no idea.
I think he is wondering about how complex this would be on NoSQL database.
Right.
Okay, great. Thank you. By the way, I was curious about that. Where came the nickname DBA Nuggets?
There is a very funny story for this. I have to tell you. The funny story is, I have two little children, 7 and 4 year old. They love Hershey's Nuggets, the chocolates. The company name is Hershey's, but then they love nuggets. So whenever they ask me to have a nugget, I will tell them like, I will give you that Hershey nugget, but then you have to listen to a sequel nugget also. So then you have to listen to my DBA nugget also. I will teach you how to do SQL Server. Then they will say like, we will listen to your DBA nugget, but please can you give us the Hershey nugget? Then that's the reason, that's the DBA nuggets came from there. So I just added my position as a DBA, and then I added the thing that my children love, nuggets.
It's really a very interesting story. And you are teaching your children to be DBA since the beginning. How old are they?
They are 7 and 4 year old. My daughter actually she's supporting me for the events like Data Weekender and then couple of other. She used to while she was in the holiday, she used to draw art thanking all of the attendees and then the sponsors. I used to attach that picture into my slides. Yeah, she used to love that, and she's asking me, "Mommy, I want to become a itty bitty speaker just like you. Can you please give me the opportunity?" Then I was like, "Oh my God, did I inspire you, my daughter? Oh my God, that is enough for my life."
That's a great story. Thank you very much for your presence, Daphne, and thank you
Thank you
for
so
your
much.
help.
Thank you so much. Can I disconnect right now?
Yes, you are
Thank
going
you.
to another track, right?
Yeah, to the track 3 for the moderation. Yeah.
Yes,
Thank you so much, everybody, for
and
attending the
thank you for
session.
your help.
Thank you. Bye.
Bye. So we have a break now, but I use this break to show some very interesting and funny videos while we prepare for the next session. Let me get the videos here. Just a moment. Just a moment to be sure that I get the correct videos. These videos that I show are very, let's say, nostalgic and very fun as well. I see these videos are very fun. Let's see if you will like me. Uh, so let me share one of them.
Tonight, a very special extreme makeover. Phil Christopherson is the loan systems administrator for Watson Furniture.
They had 100 PCs, 6 servers, and a mix of real old software, hardware, and operating systems.
Now our design team will knock down Watson's old server room and build them the Extreme Server Room.
And we're gonna fix them up. We're gonna fix them up.
One server room, one network administrator, one extreme makeover, the Server Room Edition.
101 Windows Exchange Operations Manager. Windows Exchange Operations Manager.
Well, my users are a little frustrated. I'm constantly having to reboot our NT4 servers. Our email server is full of spam. We're running multiple versions of Windows on all the desktops.
Watson Furniture, yes! You are going on vacation to the Microsoft campus in beautiful Redmond, Washington. Let's get a plan!
Wow. Man, this guy could use an upgrade. We're going to have some servers over here, server rack.
So, guys, what's the plan?
You know, I thought we could remodel. We're going to have to tear this all down.
Awesome! Yes! Okay! Are you guys ready for some demolition? These guys are doing an awesome job! I mean, it's incredible what we're doing. We've got our axes, and we're taking out the servers, and we're ripping out the network cable, and of course, my favorite, shut, swing better! God, I love the sound of that.
I hope they backed up their data. Woo!
Phil began his IT career with just one NT4 server that we, of course, just destroyed. But this is the Pentium 200 processor from that server. Page!
Build that server room! Build that server room! Build that server room!
The Microsoft certified partners here to help! Let's get to work!
We're going to put the latest version of Windows Server on there, Exchange Server 2003, and even some Operations Manager workgroup running on that machine.
He'll even be able to use group policy.
Yes!
Woo! So that he can lock down user desktops so they can't install crazy software.
Oh, no more crazy software! Let's bring in some servers!
Wait till you see what we've done with the old servers.
Okay! Bus driver! Move! That bus! You're the server room!
Unbelievable!
Isn't this awesome? Oh!
That was awesome. I mean, he was so excited.
What a moment.
Life is great. My server reboots have gone to 0. My desktops are all patched, and I've even had spare time to deploy SharePoint.
We love
The Windows Server system gave him a secure and well-managed infrastructure, made him look good to his boss, and returned love and honor to his very soul.
And one more thing, Phil. We decided to give it the 70s theme. And we fixed them out.
Here are some of the products featured on tonight's show. And thank you to our sponsor, Watson Furniture.
This video that I just saw, it was about remodeling and transformation on IT center, and it's interesting to see how nostalgic it is because they made the entire transformation. They put the IT center down just to have the ability to apply group policies and install SharePoint. So this is quite old. This is quite old. So. Thankfully, we are beyond that, and now at this moment. So let me show another one that is in some way similar. Let me share. Please tell me what you think if these videos are really.
Okay, kids, here are the stats on Joe Java.
Java, that is so 90s.
Yes, height 6'3". Ooh, very strapping. Lines of code per day 10.
Squeeze me. Repeat after me. Unproductive.
Mission career advancement.
Java and Linux. Come on. .NET, take us away.
Please, let's go save Joe Java.
Let's do it.
Oh my! Oh my God! Oh my goodness! Oh no!
Who are you? Okay, let's get busy. We've got servers to configure. We've got test scenarios to run.
got code to look at.
Oh,
Hey,
you're going
you-
to change your life.
You're the lab 3.
He's a genius.
Okay.
He's a genius.
Be a lamb.
I
What is this?
We have much to do. Let's get out of here. Keep him going. Welcome to the Microsoft platform.
Wow.
Sit him down.
Photo.
Joe. Right here. Let's be honest. How many pounds of unused UML diagrams do you have in your desk drawer?
I have been putting on some extra weight in my design center. I mean, I've just been trying to be rational, you know?
Oh, that's adorable. Listen, the key to have your designs come alive is to link them to your code throughout the application lifecycle. Here in the lab, you'll not only learn about design best practices for .NET, but you'll also get all the information you need about the would-be lifecycle tools that'll help you come up with designs your whole development team will love.
Wow.
Love, 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 love. You're going to be the hit of the dev party. What will you wear? Oh.
You.
I'm very sorry. This video is really interesting, but I think the version I was trying to show is cut in the middle. That's very sorry. Very bad. So I will put our shadow a bit ahead. So our break would be now, but I'll put our shadow a bit ahead. Our next session is from Amit Bansal. I'm not sure, I'm never sure if I'm pronouncing correctly. I hope I'm pronouncing correctly. Our next session was from Amit Bansal, but unfortunately we had an unforeseen situation. One of his employees got COVID. He is trying to handle that, so he will not be able to be here. I was about to improvise the session, but with my machine making the broadcast, it will be hard to manage everything. My machine will go down easily. So what I'll do is I'll show a recording of a session that I made some time before about Power BI data flows. And after the recording, I may be able to add some additional demonstrations, and I'll be here to answer questions and so on. So I'll cover this space with the recording about Power BI data flows. Welcome, and thank you for attending this session at the Scottish Summit 2021. My name is Dennis Torres. I'll talk about Power BI data flows, going beyond the self-serves. Let's first thank our sponsors. Without the sponsors, this conference would not be happening. So thank you very much to them. And this is me. I'm a data platform MVP, work at Betson. And you have my contacts here at this side. You can see my contacts here. Feel free to connect. It will be a pleasure to connect and ask any question you would like. Any question you would like. A picture talks more than 1,000 words. So some pictures about me, things that I like to do. And the agenda today. We'll talk about the first concepts of data flows, the data warehouse ecosystem, the Power BI ETL problem. Yes, because there is an ETL problem. Once we are talking about the data flow is to solve one existing problem. How data flow works, on-premise data gateway, and demonstrations. Many demonstrations. So data flow first concepts. Let's talk about the data flows. It's an additional Power BI ETL solution. One more Power BI ETL solution. But it's based on Power Query, so you don't need to think, oh, I need to learn a new language. No. Forget it. It's based on Power Query. It works only in the portal, not in the desktop. It doesn't work on Power BI desktop, only in the portal. And solve Power BI ETL problem. What problem? We will discover what problem in a few minutes. What we already know about Power BI. We know that Power BI is a self-service solution. This means that it's built to allow every user in the company, every business user in the company to get data from many different data sources and build their dashboards. It's a self-service solution. But we also know that Power BI needs a data house behind the scenes. Maybe some of you may not totally agree with that. So I need to explain further why Power BI needs a data house behind the scenes. A self-service can't work alone? No. Let's see why. Imagine we have a big enterprise, a worldwide company with many branches in many different countries. What would happen if each of these branches start to build their dashboards, their reports using different sources of data provided by they themselves? What would happen? This would be the result. You can imagine this organization of your data. You can imagine how your data would be like this. Worse than that. Is anyone attending this session suffering of this environment? This may happen. This may happen. So what's the consequence on this? Consequence, we have duplicated work. People will be doing lots and lots of duplicated work. And you have data that is not trustworthy. Different reports that should be showing the same numbers will have different numbers, and no one will be able to explain why those reports have different numbers. What is the correct report when the truth is that both reports are correct, but they have different point of views, and no one knows about this point of views. This is a problem in this scenario. And how do we solve this problem? We solve this problem by using a data warehouse, an enterprise data warehouse, as a backend for the self-service solution. So Power BI gets the data mostly from a data warehouse. Many pieces of the data warehouse in the enterprise. So the self-service of Power BI is still needed, of course, very needed, because the users will get data from different pieces of the data warehouse and even from outside the company. They will merge the data with information from outside the company. So Power BI is still a self-service, but it needs a backend solution, an enterprise data warehouse, to ensure the trustworthiness of the data. So let's talk a bit about the data warehouse ecosystem. This is a traditional data warehouse ecosystem. We have data source, then we use these ETLs, transformations, to prepare the data and save the data inside the data warehouse. From the data warehouse, we start to build data models. These data models will be easier for the user to understand and extract reports. And the reports can be extracted from the data models or from the data warehouse, any one of them. And how Power BI fits on this? Power BI gets the task to build the data models and build the reporting and analysis solution. So Power BI is capable to replace the data models and replace reporting tools. But the data warehouse is still an enterprise solution. Power BI still needs the data warehouse as a source of data. Otherwise, you end up with a complete mess in your enterprise environment. However, the subject of this session is data flows. And the Power BI data flows are a new ETL solution. But we already have an ETL solution here. What's the difference? Well, now we will have two. So we have an enterprise ETL. The purpose of this enterprise ETL that you see there is to fill the data warehouse. There are many rules that this enterprise ETL will follow to fill the data warehouse rules. While we also have the self-service ETL here. So the self-service ETL is the Power BI ETL that will be used to capture data from different pieces of the data warehouse, from data models, from different data models provided by the data warehouse, from outside the company to measure and give context to this information, and so on. So we still need the self-service ETL. And the purpose of the self-service ETL is to reach the final result, the reporting and analysis. So these are different purposes. The enterprise ETL has the purpose to fill the data warehouse, while the self-service ETL has the purpose to generate the reports. When you dig deeper on this, you even will notice that the rules applied for each one are completely different. These are completely different rules. And let's talk about the Power BI ETL problem. As I said, there is a problem. What's the problem? What's the Power BI ETL problem? When you build something with Power BI, we are building PBIX files. Like here, we have two files. And we have a file sales PBIX and we have the inventory PBIX. But we need to build our model inside these files. Then we build the data dimension inside these files, and the data dimension will be duplicated because we will need a data dimension for the sales PBIX, and we will need a data dimension for the inventory PBIX. So the data dimension will be duplicated among these files. This is double work And we are losing money, time, and so on. This is not good. Not good at all. And that's the Power BI ETL problem. It even makes more difficult to make teamwork because the teams have difficult to share what they produce with other teams. And then comes the Power BI data flows to improve teamwork in an enterprise level. Power BI data flow is an essential piece of feature in Power BI to transform Power BI from a simple self-service tool to an enterprise level tool. Let's see how it does that. So I said the data flows would be built inside the portal. So the idea in relation to the previous example is that the data dimension would be built in a data flow inside the portal. On the PBIX files, the developers could consume the data dimension. The data dimension is already produced there. So two different developers would share the work already created that generated the data dimension. So we will have a reuse of work and we will have a better teamwork during the development of the Power BI. And how the data flows work. Let's get into some more details. Only available in app workspaces. We can't create a data flow on my workspace. It doesn't work. It is only available in app workspace. Each data flow can have many entities. We can include many entities inside the data flow. Each data flow can have many data sources. So the entities in a data flow don't need to be from the same source. They can come from different sources. And one data flow can use another data flow as a source. This is especially powerful because it allows us to create a complete hierarchy of data flows. How will be the result? Imagine this, we have the data source. In this case, the data source on this graphic, the data source that you are seeing on that side, in this graphic, are data warehouse and cubes and data models. So it's not a production data source. They are not production data sources. They are data warehouse and cubes. And on the workspace, we build data flows. We build data flows to consume these data sources. And the workspace, the different workspace, plays an important role in this scenario because each workspace can be a different department in an enterprise, a different branch in an enterprise. So we are talking about departments sharing information between them, across them. Branches share information across them through the data flows. And we still need the data sets because the data flow is the ETL. The ETL part of the work, what we build with Power Query. But after the ETL, we still need to configure the model, configure the tables, configure the relationships, and so on. And this configuration, this model configuration, are the data sets. So we still need to build the data set. We'll see the data set in the portal, and these data sets can consume information from different workspaces. Again, we are seeing departments and branches consuming data from each other. And finally, reports and dashboards consuming the data set to show the result of the analysis and the information. Basic features for the enterprise. I'm talking that data flow is an essential feature turning Power BI from a simple self-service tool to an enterprise level self-service tool. But there are other features playing a good role in this transformation. Reusability and teamwork. This is a result of the data flows. The data flows are bringing this to us. Endorsement. This is a very interesting feature inside Power BI environment. And data lineage. Data lineage is essential exactly to prevent that mess that we just saw on a previous slide. We need to know where the data comes from. We need to know how the data was generated, where it comes from. That's what we mean when we talk about data lineage. Before going to the demonstrations, let's talk about on-premise data gateway. Why? Well, because it's very usual that we will need to connect from the portal to the on-premise environment, to on-premise servers. This is very common. So let's talk a bit about the on-premise data gateway, which is used for that. It's a software provided by Microsoft. We install this software on our on-premise environment, and the gateway provides exactly this task, a gateway to data sources inside the on-premise environment. And about the security. This drawing here is showing that the gateway uses the Azure Service Bus. You don't need to care about this. This is talking about the internals of the gateway. You don't need to care too much about this. But what is important here in relation to this, in relation of the gateway using the service bus, is how safe the gateway is. Because the service bus introduced a very safe technique for applications in the cloud to access information inside the company on premise. Azure Service Bus has a very safe solution for that. Oh, the gateway is installed as a service. It's not an application that will stay open in your environment. It's a service. It will appear as a service in the Windows service list, as a list of services. But we don't configure the gateway on the on-premise environment. We configure the gateway through the portal. So we need to go to the portal to make the gateway configuration. So in the portal, we can add gateways, we can add data sources, and what is most interesting from this is that we can create a hierarchy of responsibilities inside this configuration. Why? Because we will have a main administrator of the Power BI environment. This main administrator will be responsible to add the gateways to the Power BI environment. But this guy can delegate the gateway management to other users. So other users can be responsible for managing the gateway. And each gateway manager can delegate the access to the data source on that gateway to specific users. So specific users can access the data source from that gateway, even without not even knowing the password to the data source. I will demonstrate that. So who knows the password here? Who is managing the gateway? The developers don't need to know the password for the gateway. Here you see the definition of the users who will be able to access one data source, in this example related to the data source. Let's see a demonstration of all these that I just talked about. So Here we are seeing the on-premise data gateway open on my machine only for the purpose of demonstration. I'm showing it open. But it doesn't need to be open like this. It's a service. It's inside Windows service. In my machine, I have a virtual machine called WorkVM. And here in the WorkVM, I have some database. And I use the database AdventureWorks 2016. I'll use this database in our data flows in the cloud. Okay, that's great. Let me open the site. So here is my Power BI environment, and I can check the gateway configuration. Here in the portal, not in the client application, in the portal, I have the option Settings, Manage Gateways. So I manage the gateways in the portal. So we are seeing my gateway and connections that my gateway has. My gateway has a connection with AdventureWorks and a connection with AdventureWorks DW 2016. It's interesting that on the gateway level, I can specify administrators for the gateway because I can have many gateways and delegate the administration of these gateways. And in the connection level, I can specify the users who will be able to access these connections, to use these connections to get data and build data flows, data sets, reports, and so on. So here is the gateway. I can test connections. It takes a while to connect to my on-premise environment and tell that everything is absolutely okay. Okay, let's go ahead. I need a workspace. As I explained it, I can't create a data flow in my workspace. It may even trick us talking about data flows, but if I try to create something, I can't create a data flow in my workspace. I need to create a new workspace. So in workspace, I'll select create a workspace. And I call the workspace as Scottish Summit. Save. Here is my workspace. So in my custom workspace, I will start to create the data flows. Let's go directly to new data flow. I have 4 different options to choose. Let's analyze one by one during the session, but I will start with the define new entities. Define new entities is the base one that allows me to create a data flow getting an entity from a data source. That is it. So add new entity, and I need to choose from what kind of data source I want to get the data. It's a SQL Server. What's the name of the server? My virtual machine is called WorkVM. I'm typing the name of my virtual machine in the Power BI portal. Yes, I am. And the database is Adventure. Mind what happens while I'm typing. Adventure Works DW 2016. What happened while I was typing? The portal was checking with the gateways if there was a connection for this server with this database. It found the connection and it brought to me the authentication information for this connection. Now I have the hat of a developer. I'm a developer using the connection established through the gateway, and I don't need to know this password. Power BI brought to me the authentication password. I don't need to know it. Okay, so here I'm seeing the tables that I have on my on-premise environment. Let's choose two of them. I choose customer and product, two of the tables. So I'm creating a data flow with two entities. This data flow will have two entities generated from the data flow. You have Power Query in the cloud. I can make transformations here exactly as I can do in Power Query. For example, let's choose some columns and remove. I'll choose the columns made for translation and remove them. I don't need them. Then I come to remove columns and remove columns. According to the task that I execute, I see the steps being recorded here. And that's exactly like Power Query. I can rename the entities instead of the name of the tables. I'll call the entities as customer and product. Save and close. I have a data flow with two entities. I'm seeing in the background. Here on the background, I'm seeing the two entities, customer and product. And I'll give a name for the data flow. Let's call customer product flow. This will be the name of my data flow. Save. It already offers to me to refresh the data flow. I can choose here to refresh the data flow, but let's take a look on the workspace and I see my data flow with the options to schedule the refresh or refresh now. Let's choose to refresh now. So it's refreshing this data flow. So you saw that we have now Power Query in the cloud to create the data flows. But will you be comfortable with the development in a browser? Will this development inside the browser have all the same features of Power Query? Well, maybe you prefer to develop on the desktop. It's possible that you have this preference. And here I have my entities, including the entity in geography. Now, let's get the query for this in geography. I created in Power Query, so I can use the view advanced editor, and I'm seeing the M code used to build this query. So I'll copy this M code, copy this code. Now I'll go to the portal and I'll create a new data flow. Define new entities. Instead of choosing SQL Server, for example, I'll choose blank and select blank query because I have the M code. So I'll paste the query here. AdventWorks, DW 2016. I need to ensure the letters are in the same case. And I choose the gateway, SQL Set Gateway. Next. Oh, but it's still asking me to configure the connection. There is something strange here. Let's click this button and then magically the credential comes already filled. It's out there. It's already filled there. Why? Because the portal identified the name of the connection and the database in the gateway. So since I have access to this connection, it brought to me the authentication. And again, I don't need to know the exact authentication is being used here. I'm a developer. I don't need to know. Let's call this entity geography and use the save and close. Validating queries. The geography is the name of the entity. Let's give a name for the data flow. Geography flow is the name of the data flow. Save. Again, it suggests me to refresh. Let's use this option now, refresh. I'll go back to the Scottish Summit, the workspace. And now I have two data flows, one with two entities and one with a single entity. One created by the UI in the portal, the other created using M language. So I have these two data flows. But let's imagine now that I want to make drawings between the information of customer and the geography. I want to make analysis about where the customer lives. So I need to join these two informations. Let's create a new data flow for that. A new data flow. And that's where we get the second option. Link entities from other data flows. So we add linked entities. So I'm adding linked entity. I'm already signed in. So I just click next. And Power BI is listing to me all the workspace I have access to. This is more important than you imagine, because imagine a real scenario. Imagine that each one of these workspaces could be a department in your company. Each one of these workspaces could be a branch of your company. So we are talking about sharing information across departments and branches. That's it. I'll get the information only from the Scotch Summit workspace. On the customer product flow, I'll get only the customer. I don't need to get the product. I'll get only the customer. And on the geography flow, I'll get the geography. And then I'll transform data. So I have here the entities, customer and geography, and they have a different icon. Let me update the geography, and they have a different icon because this icon means linked entities. These entities are coming from a different workflow. I'm linking two workflows. So from these entities, I'll make a mesh queries because I would like to join the information from customers to geography. So I'll make a mesh queries as a new entity. So customer and geography, I'll mesh them by geography key. Okay. It's bringing me the result. And here at the end as a last column, I have the geography, a reference to the geography table. It's exactly the same result I would get from Power Query on premise on the desktop. So I will expand this geography and choose the fields that I would like. I would like city. I don't need the state province code. I need the name, country. I don't need the postal code. So these are the fields that I would like to have. And then I change the name of the entity. Let's call this entity customer Jill. And save and close. Validating queries. That's it. So I need to give a name for the data flow. And this will be called customer due flow. Let's use this name, customer due flow. Save. However, the portal is already giving us the bad news. What bad news the portal is giving to us? The portal is giving to us the news that we can only refresh this information if we have a premium subscription. Using the regular Pro subscription, we can't use linked entities. This is a premium only feature. This is bad. This is very disappointing because gives us the idea that we can only make the hierarchy of data flows that I talked about if we use the premium subscription, which is more expensive. But that's not true. Let's see the solution for this. But before I show the solution for this, let's see another feature. Yes, I want to save changes. So I have here my customer due flow. And here on the menu, I have the option lineage. Let's take a look on the lineage of the customer due flow. So it brings me the source of the information. It's showing that the customer due flow is using information from customer product flow and geography flow. And these two use information from SQL Server from one specific gateway and is telling me the server and database where the information is coming from. This is very important in an enterprise environment. Why this is so important in an enterprise environment? Because we need to avoid that mess that I showed to you in a previous slide. That mess needs to be avoided. And by building lineage graphics like this, we can avoid that mess. We can avoid that. So this is a very important feature. But we still can't process this data flow. There is something wrong with this data flow. We can't process it. So let's edit the data flow and discover the secret of this feature. I will edit these entities Okay. And the secret is that I can't have linked entities. Well, but besides the premium problem, what I'm doing here is using the entities from all the data flows to generate a new entity. Why would I like to expose these entities from the other data flow again? I don't have this need. What I need is the result of my data flow. And the result of my data flow is the customer due entity. The other entities I don't need. I use only to generate the result. So what can I do? I can right click these other entities and uncheck the option enable load. What I'm saying that I don't want to load this entity. And I'll do the same with the geography. I will uncheck the option enable load. So I don't want to load the geography entity. And since I'm not loading these two entities, I'm not using linked entities anymore. And by not using linked entities anymore, I can refresh this data flow. Refresh now. So now I'm allowed to refresh this data flow. And I can use this data flow from Power BI. Let's get here an open and empty Power BI environment. Use the option Get Data. And I have here the option Power BI Data Flows. Power BI Data Flows. Connecting. Again, it's showing me all the workspace that I have. It means all the departments of the company, all the branch of the company to which I have access to. So I can get information from different places in the company. But here I'll get only the customer due flow. Only that loads the data, and I have here the table customer due. So I can use the country name, geography country, and I can use the customer key, geography country to the X, and now I can see the total of customers that I have for each country. That's it. Let's publish this this report. I need to save. Let's call it Scottish Summit Demo. Select the workspace. I will use my Scottish Summit workspace. It's publishing and it's done. So I can take a look in the portal, and on my workspace I'll see the data flows I created from the portal and the report and the data set. One important feature to reuse the data across the company we can find on the settings of the data flow. I mentioned this feature is called endorsement. What this means? We'll have many different branches of the company and many different departments of the company generating data for the entire enterprise. So the endorsement is a very important feature to control the data. First, the developer of the data can promote the data flow. When a developer promotes the data flow, it means that the developer is saying that the data is correct, that work is complete and all the departments can consume that data. The developer is offering that data to other departments. This is one level of endorsement. The second level of endorsement is the certified. In this case, the company needs to define a team of people, a group of people that will be responsible to certify the data. So when the developer wants to certify the data, it will send a request for this group of people, for this team. This team will analyze the data to ensure that that data is correct, is perfectly correct, built correctly, and that data flow will be certified. So we have this feature to promote the data across the enterprise. And the users across the enterprise will be able to identify if one data source is reliable or not. On the other hand, I have shown the lineage feature before, but after I disable the load, this becomes a bit disappointing because I have here the customer due flow. Since I already published a data set in a report, I can see the report consuming the data set and consuming the customer due flow. But the customer due flow is using two entities that are with the load disabled. The lineage feature in Power BI doesn't support the load disabled. And this is not something that we will do to prevent premium subscriptions. This is something that we'll do because we don't need those entities loaded. And it's really a problem that this is not supported. But Microsoft is working a way, a powerful product called PureView that is able to work on the lineage of our data source across many Microsoft products, including Power BI. So it was to take a look on the PureView. So with this demonstration, we complete our presentation and I leave you with my contacts. It will be a pleasure to connect. Feel free to keep in touch and ask me any question. And thank you very much for attending the Scotch Summit 2021. Thank you. Hello, I hope you liked the session. The session was quite interesting. We'll have another session. So thank you, Giovanni. It was a fantastic session. If you have any question, please feel free to ask at any moment. Thank you very much, Giovanni. And I have some other videos to show until the next session. Again, these are very interesting videos. Let me get them here. This one I showed earlier, but it's interesting to show again and then compare to some other videos. Is a view from 20 years ago about how would be healthcare and mobility nowadays. Let me share this.
And finally, I get on the plane. When they make that announcement that you can't use your cell phone, well, far be it from me to trifle with the FAA. And then I realized I couldn't make a call if I wanted to because I left my smartphone plugged in and recharging at my house. Next time I am going to duct tape 2 alarm clocks to my head, rigged in series, forming a sort of Cray super alarm clock. It's a good engineering joke.
How can I help you?
Anyway, my entire life is in that phone. My appointments, my contacts, my phone number. Well, obviously my phone number.
Do you have your smart card?
Yes.
Maybe we can get your life back.
Can you believe I left my phone at home?
It's a real shock.
Oh, no. I'm late. Oh, hey! Excuse me. Sorry.
Sorry, dude.
Sorry, dude. Call Dr. Andre now.
Dr. Andre's office.
Yes. Hi. This is Steve Masters. I need help.
Just relax, Mr. Masters. Would you mind if I verify your identity?
Sure.
What happened this time, Mr. Masters?
Bike messenger? Don't ask.
I see this isn't your first encounter with a bike messenger. Oh, I see. You're in San Francisco. Now, do you have pain or swelling?
Both. And I'm a tad bit stressy. Sorry.
I can hear that. Do you need to go to the emergency room?
No, please. Is there a clinic nearby that accepts my insurance?
Let me see if I can schedule something.
Good. Scheduling is good.
All right, Mr. Masters. You've got 2 choices. One, your managed care with 100% of your coverage has a clinic 30 minutes from you. Or your wife's Safety First plan has a clinic 2 blocks away and opening in 15 minutes, but you're only covered for up to 80%.
Good. 80%. Good.
Now, do you want to pay the remaining 20% out of your prepaid medical? You have $2,000 left.
Yeah, great. Sure.
Can you approve Dr. Walu accessing your medical records? It will speed things up.
Sure. And can you send a car service like you did with my head?
Honey, it's on the way.
Nasty sprain, Steve. Bike messenger again, huh?
Yeah.
This is highly improbable.
Oh, took the words right out of my mouth, Dr. Walu.
Walu.
Walu? Sorry.
Yep. You have to stay on your toes in this city. I'm gonna prescribe you something for the pain.
Good.
Pharmacy next door, okay?
Great.
You're allergic to codeine, so I'm gonna prescribe meperidine.
All right.
You know, I think I'm gonna give you morphine instead.
Morphine? Really?
Well, should be ready in about 15 minutes. Watch out for bike messengers.
Good one, Dr. Walu. Walu.
I agree with Dr. Walu. It doesn't look like a break, so you should be fine.
Oh, that's good news. Okay. Thanks, Doc.
Oh, and Steve, be careful out there.
I'm being a lot more careful, I can tell you that. Oh.
The interesting of this first video that we just saw is the way it shows the future, but we see the cell phone is very old. We can note the cell phone is very old. And for them is something quite new, the ability to get the information from the cloud to a new cell phone, while nowadays we have everything in the cloud. We have our cloud identity on Facebook, Google, Microsoft, and cloud storage. So we have our files, our agenda in the cloud. um, just a phone device would not create any kind of problem. Anyway, this other one is only a comic video, but is related in the way that is related to cell phones.
Innovation, originality, revolution. What do these words have in common?
Oh. People will talk about this phone the way they talk about a piece of art.
This phone breaks every paradigm that we've ever had.
They've done it. They've really done it. They've reinvented the wheel.
Introducing the Windows Mobile O Phone.
When people see this phone for the first time, they'll say, oh.
The first time I saw this phone, I thought, oh.
I love the circular screen. Circles symbolize mobility and progress. Clocks are round, the globe is round, the wheel is round.
Is this way up? Wait, which way is up?
This is more than thinking outside the box. We're nowhere near the box. The box is on Saturn or Jupiter, whichever's farther away.
Now, coding for the O phone is so easy, a 5-year-old can do it. In fact, even a 4-year-old can do it. All you need to do is use the right GDI APIs, such as get client circle instead of get client rect, and draw circle instead of draw line.
I was dreaming in concentric circles at the time, and I was thinking, oh, hold on a second. Getting an O mail. Hey man, how you liking that new O phone? Is it cool?
Yeah. Oh, watch out for the places where you query the width and the height, because you want to query the circumference and the radius of the O phone instead.
My guys had thought they'd mastered Windows Mobile, but they're always game for new challenges.
I love the keypad. This is the first phone that lets you put the numbers wherever you like. I like the number 1 down here.
The phone is a challenge, yes, but you either rise to the challenge or you throw your phone out the window. And I really like my window.
I love ringtones.
Here's a new innovation for you. Microsoft's Quick Fetch Plus. Let me show you.
Picture me as a pretty ballerina, and I'm in a tutu, prancing around a stage. What does that image convey? That I'm on my toes. I'm ready for anything.
To me, the O phone says expect anything. As a developer, you have to be ready. Ready for anything that comes at you. We're going to fix that in our first ROM update.
We have some additional time before Kevin kicks in, so I will share another video, a technical one this time.
welcome everyone. We're going to get started with a demo of the SQL tool belt, and I'm going to leave you with our pre-sales engineer, Chris Randerveer, to take you through that. Go ahead, Chris.
Thank you, Annabelle, and again, thanks everyone here that's on the session today. We're going to talk about the tool belt and what that is, and how people actually use this whole thing. I think when we start talking about the tool belt, really what it is obviously is a conglomerate of different products that we've developed over the years and packaged them all up into this nice licensing model that we call the tool belt. But the biggest component within that tool belt is this product that we call SQL Change Automation. This is where all the magic happens. This is where really the impact of what we're doing here at Redgate all comes together, which is really to introduce the database into a life cycle that no longer impedes software delivery. This has historically always been the challenge, obviously, for a lot of our customers, especially as we become more and more agile with our application code and delivery of that code. Leaving the database behind has always been that challenge. So now what we're trying to do is to have our customers, with using the tools and the features within that tool belt, to really start to include the database along for that transition, and now alleviate the database from being viewed as that bottleneck in terms of software delivery. So I'm going to go through a normal process change here, a day in the life of a developer, and call out different tools, I guess you can say, or different features within the tool belt, where they come up and where that value is within delivery. Okay, and we'll take changes, we'll capture changes, we'll go ahead and commit and push those changes, and then talk about what we can do in terms of validation of those changes, and then deployment of those changes. Okay, and those kinds of tools that we can also integrate with along the way. Any questions, folks, as I go through this half-hour session with you, by all means, just go ahead and put that in the chat window or in the QA section there. And as we kind of rope around the back end of this call, I'll try and come into those questions and answer them accordingly, okay? All right, let's kind of begin this journey here. So I'm showing on screen Management Studio. This is where we're all making changes and managing our environments, obviously. The first product that I really want to talk about here is more of a foundational tool, which is SQL Source Control. When I talk to customers that are new to this process, new to this journey, if you will, I always begin at the foundation. I always look at this as a house being built, right? I want to first and foremost have a strong foundation. If I have a strong foundation, then I can go ahead and start framing my house and I can start building it accordingly. But that foundation is where everything begins. And in this case here, this is going to have to be viewed as source control. Source control for the database, that is, okay? I talk to a lot of customers every day. I'll ask that question usually about whether or not you're source controlling your database. I get a 50% yes, 50% no to that question. Those folks that tell me that they are source controlling, as I continue to ask questions there, I'll find out that they're actually not really source controlling the entire database. They might have some selected tables out there. They might have some stored procedures out there. What we're talking about is the entire database, okay? And we're going to be using some engines that you might be familiar with, SQL Compare, for example. So when I talk about SQL Source Control, this is not to be confused with Git or Azure DevOps or Subversion. Those are version control systems. What SQL Source Control is a plugin here to Management Studio, and it bridges you over or links you over to that version control system that you might be currently using. Currently, we support everything out there. I think right now, most of my customers are pretty strictly in Git or Azure DevOps, or Git within Azure DevOps. There's a little sprinkle of Subversion out there, but that is fading away, I think, over the last 12 months in terms of my conversations. I'm going to be using a specific environment here for my demonstration. This is my SQL Server Central environment, okay? And you can see within the licensing, you're going to get an introduction of different tabs now within Management Studio. The Setup tab is going to give you a nice little visual here in terms of what version control system this database is linked to. In this case here, I'm going to be using the old centralized version of TFS. You also notice here that you've got some comparison and some filtering options. These are from the comparison tool. If you're familiar with SQL Compare, this is our flagship product here. This is how Redgate was initially established. And if you have no exposure to compare, do yourselves a favor and take a look at this product. It will save your life in terms of operations. It allows you to just basically look at a source environment and a target environment, compare those two, and then compare will show me what is different between those two environments. And then I can go ahead and actually take those changes through compare and deploy to that target environment here. And there's some really nice features in terms of being able to, ignore certain attributes. For example, I might not want to, bring permissions over or users that are present in development to say a higher environment where they're not supposed to be. So really nice value add in terms of that functionality. The locking tab here, again, self-explanatory. If I'm in a shared model, obviously I think this is something of a challenge for a lot of my customers, right? I have a shared development database. I've got multiple folks making changes against that database. And oftentimes this causes conflicts, right? I make a change to an object, a colleague makes changes as well. I submit my changes for review. The same can be said for my colleague. And now I'm leaving it to some other entity, usually a DBA or some individual there that has to kind of manage that. Whose change came in first, whose change actually gets deployed first. This is a problem, obviously, within the life cycle here. So being able to lock an object down is something that I find to be very advantageous in a shared model. I can come into this database, for example, at any time, open up an object, and you can go ahead and lock it down. And what this does here, obviously, is it gives me a nice little visual indicator here in terms of this object being locked. But in terms of just the locking tab here, this UI will give the entire team that visibility here of who has this object locked, most importantly, and the type of object. And again, if I lock this object, this is not the only thing, I'm not the only individual that can unlock it. Anybody within the project can unlock the object. It's just meant for that preventative maintenance aspect here. So this is a nice key here. If I'm not in a shared model, obviously, this is not something I need to worry about. I'm now in a dedicated model, very, very much so like the Git workflow, right? I'm working independently. I don't worry about anybody else conflicting with my work. I'm committing changes locally as well. When I'm ready to expose those changes, I then do a push, and then those changes then become viewable to the rest of the collective out there. If this is the scenario, then the Get Latest tab will then be something that gets initialized within this workflow. And what the Get Latest tab does is it does just that. It goes out to that common repository, again, using the comparison engine, looks for any changes. So this is where I would see those commits and pushes from my other teammates now that will be shown here, and then allow for me, obviously, to go ahead and bring those changes down into my local copy of development. And this is really within a dedicated model, how the teams stay in consistency with source control. Okay, I'm going to go through this process, kind of show you what I'm talking about here. So when I take a database, for example, and link it over to a source control system, I'm going to open up Azure DevOps here. This is my repository for the project, as you can see. And I've got a couple of folders here that I've established, one for my application code and the other here, obviously, for my database code. And within this folder structure that gets created by SQL Source Control, each of these folders are going to have the current state of those associated objects. For example, I'll take my stored procedures here, and I'll pull up one of these guys here randomly. Okay, all of these are now SQL scripts in source control, all in the form of create scripts, as you guys can see. Okay, these now become the source of comparison. All right, so now as a developer, I can make changes in that database dynamically. I don't have to do a checkout, check in. I don't have to do anything of that nature. Make changes to those objects in the database dynamically and allow SQL Source Control and the engine of compare to constantly look at the state of these create scripts and compare them to the state of those associated objects in the database. And this gives me now as a developer an opportunity to also review those changes, make sure that those changes are in fact the ones that I've made, and then from Management Studio, be able to go ahead and make a very detailed comment as to what those changes are, maybe even associate those to a user story or to some change request, or however those folks are tracking those changes as well. Okay. Let's get kicking off here. I might want to start off with doing some development work here. One of the first tools I want to just quickly call out here, which is a really nice one. This is something called SQL Search. SQL Search is it's a piece of freeware, to be honest with you right now. But in terms of just understanding where everything is. You know, we as developers, we're moving in and out of different database environments constantly here. So this is something that I find to be very advantageous. So I can come into SQL Search, for example, and let's say I might be looking for the contacts table. Okay, so you can see I could put a wildcard search in here. It'll pull up everything with the name, contacts in it, the schema, the database that it's located in, also the type of object here as well. And of course, if this is the exact object in which I want to work with, I could just double click on it and it'll bring me right to where that object lives now within the database. This is a really nice tool. I like that just to keep me honest, if you will. Now that I know where that object is, I'm beginning to go ahead and make some change. Let's just say the business has decided that we're going to engage our customers in a different way. So we might want to start to collect some social media, for example. One of the other nice features about the tool belt that I find very advantageous on both sides of the house, both developers and for operations folks, DBAs as well, is a product called Dependency Tracker. Dependency Tracker is really nice because it gives me a nice visual relationship of how my objects are. So, for example, because I've been given some charge to make a change to that contacts table, I can right click on that object here and you can see that I can view this dependency diagram here. This will pull up SQL Dependency Tracker and this will give me a nice overlay, a visual overlay of how that contacts table looks and also all of the associated objects here to it. If I click on this guy here, you can see in the lower right hand corner, I've got some dependencies. I work with this database all the time, so I already know that I've got a stored procedure, for example, that works with that contacts table. So if I'm making a change to that table, it's safe to say I might want to also take a peek at that stored procedure as well. I can right click on this as well. I can see how the SQL looks for that object in version control. Just a really nice feature to have to really understand what I call the ripple effects of my change, right? I want to make sure that when I do make a change, I'm not going to cause problems elsewhere. Another nice product there within the tool belt. All right, now that I've got that visibility, I think I'm safe to go ahead and start making change, right? So I'm going to go ahead and open up the designer here. And you can see we're already engaging our customers here with grabbing their LinkedIn profiles, grabbing their Twitter IDs here. Let's say TikTok's all the new rage, right? So why not? Let's go ahead and grab their TikTok, I don't know, whatever you call a TikTok, an ID, an account, something of that nature. We'll go ahead and create the TikTok column. Go ahead and save that off. All right, because I saw that in Dependency Tracker, and I know that I work with this database all the time, I'm going to go ahead and make a modification to that get contact store procedure as well. We reduce this down here. I don't know why this always opens up with 194%. Now, before I make any modifications, here's another tool. And I say tool lightly. This is a feature. This is another flagship product that I really think most of our customers really know Reg API. If you do not know about SQL Prompt, then this is going to be your lucky day. Anything that you folks are doing SQL-wise, this tool is meant for you. This is our auto IntelliSense tool, auto suggestion, auto completion, auto formatting, snippets, tab coloring. I mean, again, this will change your life with respect to making you writing SQL more efficiently. One of the things that I want to call out here, you notice as I bring that stored procedure up here, is that this is underlining here. So this lets you know that we're flagging this for some code analysis sweeps here. For example, as you can see, as I hover over this, my entire procedure body is not enclosed properly with a begin and an end. I've got the dreaded select star statement. This would kill me in operations in my day. When this kind of came across and I deployed this into a higher environment and brought that down to a crawl, you can bet your bottom dollar I was trying to get the developer who promoted that change to, let them know exactly how to get that a little bit more tightened up here. But this just, again, gives me some really good visibility on how to get that code tightened up here. One of the nice features is particular here. I can put my cursor after that star, press tab. You can see I can expand my wildcards really quickly. This is a nice feature as well. Execute. One last thing before I kick off here, because I do want to show another value add to SQL Prompt. You'll notice one thing that I think a lot of my customers ask about is data. Okay. If you have the need to source control your data, static data, I should say, in development, this is also a feature within the tool belt. If I right click on that database, come down here to other SQL source control tasks, you can see that I can link or unlink static data. This is going to pull up all of my lookup tables here. You can see that I've got RSS feeds, I've got country codes flagged. So now in development, if I'm doing some inserts here into those tables, I'm going to track that change no differently than I can an object change within Management Studio. Let me show you that played out. And I'm going to use snippets here as well. Okay, so I'm going to open up a new query window. And snippets is a shortcut, for example. So I'm going to do an insert into that table here. I already created a snippet where I'm going to do a double line. I'm going to tab. You can see it auto-complete into that statement. And then I start typing my table name. You can see it already starting to populate. I tab. And now I have this nice little boilerplate template here for me to start to begin doing some inserts of data. Okay. Very poor data representation here. But in the interest of time, I think we all get what we're doing here. I'll take my nulls out. Give it some value and execute this as well. Okay. So a couple of normal development changes that you've made. Also a little call out here. You notice over here in Object Explorer, you start seeing these little blue blobs or globes starting to appear. If I open up this folder, it'll actually end up at the actual object in which I've made a change. Okay. I do see the questions in there. I will come back to you in terms of Azure Data Studio for sure. Hang in there. With respect to this change here, you can see, as if I'm a secondary developer now, this table has some changes to commit. So if I needed to make a change, for example, into this object, I want to make sure and go out to whoever made a change. When can I expect to see that actually in source control? Because I'd want to work with the most current state of an object before I actually commit my work. So a nice little speed bump, if you will, preventative maintenance in terms of that conflict. When I'm ready to go ahead and commit that change, I'm going to come into source control and I'm going to hit commit. When I do so, here's that comparison that's going to take place. And again, looking at the state of those scripts out in source control and comparing them over to the database version. So now as a developer here, I can go one by one and inspect and make sure that in fact, yeah, this is actually my change that I've made here. So it's giving me a nice visual delta to show me what is different between those objects, all the way down here to my data change. Okay. Now, as a developer, obviously, before I go ahead and commit these changes and talk about the pipeline, visibility is key with respect to the value of source control. At any time, you can right click on an object on a database here, come down to view history. This is always going to show me or the teams, what has gone on with this object from the very moment that I made or committed this initial project, created the baseline, if you will, to all the changes that I might have done since then, right? I can see how that object has changed. I can see who on my team made that change. I can see when that change was committed into source control, right? You want to, of course, have a little bit more robust commenting here. Don't take my example as best practice. But this is really the ability to just by reading those comments, you can get a very good idea as far as what state that object is and how it got to that state. And then down here again, a nice comparison in terms of what revision that database was and what that revision went to based on that change as well. Okay. The idea between SQL source control or via version control should be able to be managed here. This is where you as developers are the most performing, the highest productive. All right. I don't want you to move out of this environment to do anything else from a version control standpoint. And as you can see up top here, you can also now make a very detailed comment as to what those changes are. If you are working within Azure DevOps or TFS, as you can see, hopefully in the background, and you need to associate this with a work item or a user story, whatever that number was provided to you, just put a #A and then that item number and then your comment. And this way that can all be correlated over in Azure DevOps/TFS. Made a change. Okay, again, stay consistent with my poor commenting and go ahead and commit that change in there. I'm just pushing the object changes in now. I'm going to keep the data change back for a little bit. And now that I push that change, I move on to my next piece of work, whatever that might be, okay? But now that I have that in place, this allows for me to dynamically capture changes and keep everybody visible to those changes. But now that I have that in place, what's the next piece of this equation? And that is really, I want to validate those changes, right? I want to make sure that, in fact, these changes aren't going to cause me problems as I move that closer and closer to production. The nice thing about Azure DevOps for a lot of my customers is this is all within that product, this family of products. So I can have a repository version control, and I can also create a nice build and release pipeline here as well. You can see, based off of my commit, I already have a validation process kicking off now, where we're doing things now like automation, automated builds, I should say, for the database, where I'm going to validate the consistency of your schema. We're going to be looking for things like invalid objects or broken dependencies, anything obviously that would not allow me to recreate that database successfully based off of the create scripts that I have in version control. Testing, as you can see now running through this process here, this is a little bit of an area that we didn't take a flyby on here. SQL test is another feature within the tool belt. I always talk about this with my customers. A robust testing function within the life cycle, I think, is imperative to really adopt. Okay, SQL test, if you're not familiar with this, this application has a couple of different frameworks here. T-SQL-T, if you're familiar with that organization, we support those folks here at Redgate. They are familiar and popular with a lot of the unit tests that you can run for SQL Server. And then SQL Comp is the other framework, more for code analysis, looking for example, these SP underscores. This would kill me as well in operations, looking for these kinds of things, those select star statements and those stored procedures as well. So you can create, we give you a lot of great tests out of box with SQL tests, but there's no limit to the amount of tests in which you can create there. And you can run these at any time during the life cycle as well to get that feedback, right? The feedback loop needs to be hopefully as close to development as possible here. Also get some code coverage, right? How much of my application code is actually being covered by a SQL test? Okay, so again, really good stuff there. Where my customers go, obviously, is as I'm creating those tests, let's go ahead and introduce that into this automated workflow here. The build has already completed. I just want to quickly show this on screen to you folks on how that got created. What I'm showing here are build and release extensions that we have provided for, in this case, TFS Azure DevOps. One of the value adds to the Redgate workflow is that we're completely agnostic to whatever might be in your environment now, okay? You might be using other tools like Jenkins, for example, or TeamCity, or Bamboo, Octopus Deploy, really popular release management tool, Urban Code Deploy, Excel Deploy, you fill in the blank, okay? We have the ability to plug into whatever that looks like there. We're not gonna ask you to retool everything in order to receive the benefit of this workflow here. This build extension is really primarily for Azure DevOps. As you can see, a couple of things you guys need to do in terms of configuration of those extensions. In this case here, I'm building a source control project. I'm going to map out to where that database folder is that I created out in version control. And what do I want that package to be labeled as? So after a build is hopefully successful, we're going to package that up into a deployable artifact, which is called a NuGet, glorified zip file, to be honest with you, also Microsoft technology. And then also, where does that build take place here? Okay, so I have right now pointing it to a temporary SQL server. You can also use local DB here. Local DB recommended, depends on terms of your environment. I now work with a lot of customers that have cross database references, for example, or linked servers. Local DB wouldn't suffice in that kind of scenario. So I think more customers are using just a temporary SQL server to run those builds on here. I have my database area here blank, and what this is doing is it's actually spinning up a temporary database for the purposes of this validation piece here. And what's going to happen is, again, using the engine of compare, we're going to take those SQL scripts in version control and actually deploy them to that temporary blank database, recreating it from the ground up. This is, again, how we're going to be checking for the consistency of your SQL. You can see here also those tests that we've created in SQL test. I'm running that in an automated fashion as well. Again, feedback instantaneous to the developer. If anything failed here, build failed, some testing has failed, this is immediately known to the developer, right? You're not waiting for some other individual in operations to provide that feedback in about a day or a week's time. Okay, instantly known. You know why that occurred. Make the necessary changes. Put it through that same life cycle until we get some success here. I've got another product here also that I want to talk about, which is called SQL Clone. If you have an opportunity, please go to Redgate's website. All of these products are available for trials. Take a peek at that. What SQL Clone is, very quickly, is a product that allows for me to leverage a source database, take an image of that database, anywhere between 1 and 64 terabyte in size, and then provide what we call clones or lightweight copies of that database. And I can do that with a very extreme time savings as well as a disk space savings as well. Just imagine I had a 2 terabyte database, for example, and I've got about 10 developers that all want that environment to work against. The ability to do that with storage is already going to cause me a little concern. But now I can actually give them a clone of that database, and locally that might only take about 50 megabyte in size, okay? So keep that in mind. A nice product for you guys to take a peek at after this session. But what I'm using SQL Clone here in terms of this validation is, for example, I'm going to already have an image of my production environment in place. I'm going to create a clone of that production environment and then actually deploy or sync my changes to that clone of production. So what I'm actually doing here is a deployment to my production environment, but not production, if that makes sense. In terms of releases, same thing, okay? I have a release here that I have configured. Let me show this out here as well. This is a mock pipeline here. This, this is not a one size fits all. You can see that I have a database build artifact upon successful generation. I'm going to allow it to automatically deploy all the way up to UAT. And this is where I have a manual intervention step that stops everything for the purposes of just that. Allowing for my operation folks, my DBAs, to take a look at everything, review the scripts, and again, give it maybe even a sign off here. From an auditing standpoint, this is best practice as well. We want to make sure that we know who and what has actually deployed this into a higher environment. Okay, and again, all of my environments here are all set up in the same manner to create a release artifact from that build, and then obviously to deploy that release artifact. This is where you can establish, which targets get this change, obviously. But the biggest reason why I have that separated here, let me bring this up really quickly, is this export path that I have created that really gives me a good look at all of the logs and reports that are available to me here. This is how I can get my DBAs on track here. So here you can see I've got an integration environment already released in there and testing as well. Here's what we're going to give you to all of those environments. First, we're going to give you some snapshots as to what that source and what that target environment looked like before we did a deployment. So in case there's any need for maybe a rollback, this is something that will be very advantageous for you guys to have. But within this reports folder here, this changes.html, this is something that I find to be just really just a home run for my operational folks here. So this is where I can come in now. I can see what objects are actually part of this artifact here. And this is how I can kind of track the change. Here, for example, my contacts table, right? I had a Twitter ID column, I dropped it. That's why it's shaded in red. I re-added it. And then now also my introduction of my TikTok column here. Okay, so I can go through each of those object changes. Any coding issues, okay, those same things that we saw way back in development with SQL prompt. I'm also given another opportunity now as a DBA to take a look at that and be given a heads up at potential areas of concern there. And because we're using the comparison tool to do that progression, all we're doing is doing those compares. Any kind of warnings would be presented to me here as well. Maybe I dropped a column by mistake and we forgot to take adherence to that data that might also be lost. And then lastly, this is the script. Okay, this is what SQL Compare is doing for me automatically. This is where you're going to see your alter statements. Okay, my alter for my table, my alter for my stored procedure. You should see a little bit of a highlighted area here. These are going to be where the coding issues are. So I'm not wasting a lot of time looking through this script, trying to find what those issues that we're complaining about. So it just brings my eye right to it. This is now the source of deployment. As I take this script and I keep moving this all the way onwards and upwards into production. We're at the top, or I should say, yeah, we're at the top of the hour here, folks. I've given you, I think, as much as I can within that 30-minute time. I want to thank you for giving me the time today. I hope you're enjoying PASS. Ideally, if there's something else that you might want to come away with, or there's a little bit more of a deeper dive, by all means, please reach out to the account teams here at Redgate. Make an appointment with myself or one of my colleagues in pre-sales. We'll be more than happy to do webinars where we can really get into the nitty-gritty of this tool, the value add that it brings to the entire process. This will be something of a pleasure for me to do so. But thank you again for the time, and again, I hope you enjoy the rest of your day there. There were a couple of questions there, if Annabelle, you don't mind.
Of course, yeah, a few questions for you, Chris. So the first one is, do we support the latest version of SSMS?
We do. We do. We are in lockstep with Microsoft, folks, so just keep that in mind.
And will these plug into Azure Data Studio?
Azure Data Studio. So right now, I know we have SQL Prompt available within Azure Data Studio. As far as SQL change automation, this is something that we are working very diligently to get support for. So I think this is going to be something within the first quarter of 2021. This will definitely be something supported within Azure Data Studio.
Great. Well, thanks for answering those, Chris, and thanks everybody for attending. Like Chris said, if you want to reach out to us for more info, you can visit us at the virtual booth throughout the day, today, tomorrow. Chris will be on tomorrow. And also just drop us an email. You can do that via the virtual booth, send a request, and we will be right back in touch with you. Thanks again for your time today, everyone. Bye-bye.
Thanks all.
Want to look, see, I have the best seat in the house by far because I get to look out at the water and the bridges and pretend like I'm not in here talking to you people.
So we are ready to start our next session. We have here Kevin and Sander with us. Welcome.
Hi.
Hello, welcome. What city are you located? Are you two located?
Apparently Sander is having. Can you hear us, Sander? Anyway, whilst I'm trying to get hold of Sanders to get his sound up and running, we're actually both located in a city called Zoetermeer in the Netherlands.
Oh, Netherlands. I still would like to visit the Netherlands as soon as this pandemic gets over. Cool. I have a video here to show to you. Let me see if I got the right video. Sorry for the video being blocking this way. After a day of streaming, my machine is already almost going down. Sorry about that. Let's see if we can repeat only the last piece. Have we managed to capture the idea of about you, Kevin?
Yes, you have. I'm kind of hoping you've got the similar one for Sander as well. Otherwise, I'm guessing
Yes,
we'll be filming
yes.
the interview for him.
Yes, we have. But tell me, there are canyons like this on your city or on other cities of Netherlands?
Yeah, I mean, some of it is fairly similar.
Usually, the city that is most famous by these canyons is Venice, but Netherlands, usually we know that is a bit below the sea level, but I don't know much about this canyons on Netherlands.
Yeah, so pretty much most of the Netherlands is actually below sea level in one way or the other. I'm actually from a different part of the world, and I was going to cover that during my bio in the session because I think my accent gives it away a bit for quite a few people. So I'm actually originally from the southwest of the UK.
And is living in Netherlands for how long?
Just over 5 years now. Literally last 5 years ago, last December, I moved over from the UK.
Interesting. In fact, I'm living in Malta for almost 4 years as well. So the environment is new for me as well. Almost the same time. So let me see if I manage to show this other one without so much blocking. I put the other video. So, Sander, have we captured the idea about you, especially your work environment? Was that picture your regular work environment?
Sorry, say it again.
Was that picture in fire your regular work environment?
Well, that's kind of my state of mind in normal circumstances. So,
oh, I can imagine. Do you two live in the same city?
we live in the same city. Yeah.
So you keep this partnership speaking together by some years already?
Yeah,
Oh,
I have.
no.
We have. At some point, we decided, like, hey, we can do a joint session, and then this came out of it, and then we've been doing similar kind of sessions, like more than a year and a half, something like that.
Yeah.
Great. So let's jump into the session. I'm curious to see the biggest challenge about database DevOps. So you can share your screen. Who share the screen? Or you two?
We're going to swap between each other, sharing the screen, which I think is going to make this quite an interesting session, because I've yet to use StreamYard, so this will be an interesting experience for me. So, which is fine. I can still share this screen. So, yep. So, which screen do we think is going to let me share? I've got 3 separate screens. Ah, that's good. Now, this is very similar to. I'm kind of hoping. Yes, I can actually see the screen share as well. This is quite good. Very impressive, this one. Right, so do you want us to start? Do you want us to wait for people? It's got a few more minutes.
You can start. The stage is yours.
Ah, in that case, we will get started since this was cheap. Okay, then. So, welcome to today's session, Azure DevOps Duet, Water Edition. It's about how the development team and the operations team must bond together and start using Azure DevOps for data platform deployments. Now, before we get started, and as you may have seen on the video earlier, we'd like to thank the sponsor for today's event. In addition to that, we'd also ask to remind everybody about the Mortar user group. One thing I forgot to ask before the session started, how are we going to deal with questions? I'm hoping that we can see the questions on the chat. We shall see.
There is an area, a button called comments. You can see everything that anyone writes on YouTube, from YouTube. So you can see the questions. You decide how to handle in the middle of the session or in the end.
Yeah. So whenever one of us talking, Sandra, the other one can keep an eye on it. Sure. Fine. So over to you.
So for the next 60 minutes, we'll be talking about Azure DevOps, which allows you to do the full application management lifecycle. This is from creating a work item all the way to its release. And we'll be discussing both the cloud and on-premise versions of Azure DevOps, as well as its features, including source control, the boards, the pipelines, artifacts, and test plans. And at the end of this session, you will have a basic understanding of the main features of Azure DevOps and how it can be used with data platform deployments.
So in this session, to give it some context, one of us is from the SQL development team and the other from the SQL operations team. Our manager has decided that both teams will merge into one DevOps team, so that we're all one big happy family. In addition, we've been asked to make it future-proof for data engineers as well.
In reality, this should be a real gradual process. However, since this is only a 60-minute session, we've taken it upon ourselves to speed up this process. In addition, our manager has decided that the development team lead will be the Scrum Master and the operations team lead will be the product owner.
Now, for those of you who don't know, a product owner is responsible for translating business needs into workable backlog items for Scrum sprints, which means that they must meet the stakeholders at various levels within the business. In addition, they are ultimately responsible for prioritizing those items, even though they may get input about those priorities from various stakeholders.
And the Scrum Master's role is to empower the team to do those backlog items by encouraging how they work and removing any impediments if they appear.
Yeah, and before we go any further, even though we did have those really good videos to introduce ourselves earlier, let's introduce ourselves again, Sander, in a slightly different way.
Yeah. So I'm Sander, and as you've seen in the video, I'm from the Netherlands. I'm a Cloud and Data Center MVP, which I'm really proud of. I'm a major contributor to the DBA Tools project. If you haven't heard about DBA Tools yet, go and find out at dbatools.io. It will change your life as a DBA. I have worked in a variety of environments, from agriculture to financial industries like pension funds to healthcare. I've seen it all. You can follow me on Twitter. As you've seen in the video, I have a blog. And if you have any questions after this session, feel free to send me an email. All the demos you'll see today will also be on my GitHub page under the presentations. So just go to my GitHub, go to the presentations, find the session, and you will find the demos right there. And you can do whatever you want to do with them. Change them, reteach them. They're yours. They're out there. And now Kevin has a slightly more complicated bio than me. So go ahead, Kevin.
I think, to be honest, maybe I should back to the video version on that comment. So, my name's Kevin Chan. As you saw in the video, up until very recently, I was a senior database architect living in the Netherlands. However, my role has very slightly changed very, very recently. I'm now a lead BI and analytics architect living in the Netherlands. However, like I said, and as you can probably tell from the accent, I'm originally from the southwest of the UK. However, I live in the Netherlands due to the fact my wife is Dutch. So basically, I'm an Englishman living in the Netherlands, working for a French-based company because he met a woman in Australia. Every time I say this out loud, I realise I sound a bit complicated. Now, with over 24 years experience in IT, I've worked in various sectors like the video showed, and indeed I've supported some companies in the top 10 of the Fortune 500 list. I've worked with all versions of SQL Server in one form or another, and I have various certifications, including recently becoming a Microsoft Certified DevOps Engineer Expert, which is fairly relevant for today's session. I'm also a Microsoft Certified Trainer and a Microsoft Data Platform MVP. And just like Sandra, you can find all my social media details below at the bottom of the bio here. Anyway, Sander, first thing to discuss is whether to use Azure DevOps Cloud Services or Azure DevOps Server. For those who aren't aware of the difference, Azure DevOps Server is the new name for TFS, which is the application you install on premises to do your application lifecycle management. However, now it's been rebranded to look and feel just like Azure DevOps Cloud Services. Personally, Sander, I'd like to use Azure DevOps Server for security and reporting purposes. However, the downside is we'd have to build one or more servers with Azure DevOps Server installed for business continuity reasons. Plus, we may have to wait a while for new features to become available due to the cloud-first strategy. In addition, we'd have to maintain and patch all of the servers that we deployed for it.
But if you use Azure DevOps services in the cloud instead, you wouldn't have to patch and maintain anything because it's all handled by Microsoft in the background for you. Plus, it's easier to install extensions from the marketplace.
That's true, and we can still secure it in Azure. Besides, whichever we use, we must still consider security and compliance anyway to keep our auditors happy. And in addition to that, it's easy for us to connect it to Azure Active Directory, which we need to do if we want to connect some of the newer services, especially those relating to data engineering services, to a Git repository within Azure DevOps. Luckily, Azure DevOps is well structured and easy to manage.
So the main point we want you to take away from this section is that if you install Azure DevOps Server, you have to patch and maintain everything yourself. Whereas with the cloud-based version, everything is maintained in the background for you. And your Azure DevOps organization needs to be connected to Azure Active Directory to easily integrate services like Synapse Studio with an Azure DevOps repository.
Yeah, so talking about the structure of Azure DevOps, let's see if I can do this fairly seamlessly now. So as you can see here, Azure DevOps actually has its own hierarchy. At the top, you have your service, which has access to own organizations, which you can see on the left-hand side here. Now, for example, an organization can be the company you work for, or if you work for a large enterprise, it can be just a division within that company, or a personal one that you've created for test purposes, like you can see here. In addition to that, if you have the right permissions, you can change various settings at the organization level as well. So, for example, if I click on organization settings, you can see I can view some overview settings here. In addition to that, I can view all the projects that are within an organization and manage them. I can view other things like users, billing information, usage, extensions, which can be fairly important to see which extensions you've got installed for your organization. As we were talking about earlier, you can connect your organization to Azure Active Directory as well, which brings about some benefit. As far as security settings are concerned, you can set various policies. Plus, you can fine-tune permissions at the organization level as well. For as far as using Azure Boards is concerned, this one is fairly important, the process section. And this basically allows you to manage which projects use which particular process in Azure DevOps. You can change some pipeline settings at the organization level as well. For the repositories at the organization level, you can actually change a couple of settings there. The most significant one being the default branch name for the repositories. As you may be aware, there's a little bit of controversy regarding the origins of the master naming convention in Git. With this in mind, Microsoft has now put a setting in to allow you to change the default branch name to something else instead. And in fact, GitHub have taken a similar stance now. So if you create a new repository in GitHub, it would actually have the default branch called main instead. In addition to that, the Git for Windows client also now gives you this option as well. So it is quite a nice unified setting now for everyone. So if we go back to the main organization view here, you can see that each organization has run on the projects, as you can see here. And if I click on one of these projects, you can actually see all the services that Sandra was talking about at the start of the session on the left-hand side. So boards, repos, pipelines, test plans, and artifacts. And just like at an organization level, if you have the right permissions, you can change various things at the project level as well. So if I click on project settings, you can see again, I can change some general settings. For example, I can manage the teams. If I click on the default project team here, for example, I can add and remove members. I can fine-tune permissions as well, and not just for the teams and individual users. I can also create logical groups to fine-tune permissions on as well, which is quite a good thing to do, especially if you need to do, for example, separation of duties within one of your Azure DevOps teams. For example, only certain people can approve releases. And if I click on the default SQL deploy team, for example, you can actually see the kind of settings that can change here. You can also change some other settings. You can create service hooks for third-party applications. You can manage your board settings here as well. Connect that to a GitHub repository if you happen to have them. You can also change some pipeline settings at the project level as well, as long as you have the right permissions. If I click on the repositories settings at project level, you can view all your existing repositories. Again, you can change the default branch name. So if you don't have the option to do it at an organization level, you might still have the option to do it at a project level. Plus some interesting policies and other things you can change as well here. You can view the total size of all your artifacts per project. And finally, you can set some retention for test plans.
Now you're talking. Remember, there are other things that we can configure if we dive even deeper into these settings. And so the main point we want you to take away from this section is the way how Azure DevOps is structured. So anyway, now we've covered the main admin stuff. Let's cover version control options with Azure Repos, which is a feature in Azure DevOps.
Oh, you mean like SourceSafe?
Oh, I actually used this in the past, but maybe something a little bit more modern, since Azure Repos supports multiple version control systems. Something called Git.
Right, that will only be for your development work, though, right? Because it sounds like version control would be complicated for the ops folks to learn.
Well, actually, I think that you'll see when ops teams start to use version control systems, they will start to perform better. At the company I worked for, we started to put all our scripting into source control, which is managed throughout the IT department and shared among each other, and they can all change it accordingly. So that works really efficient for us.
Well, I'm always game for efficiency, Sandro, so tell me more.
Well, like I said before, Azure DevOps supports multiple version control systems. It supports both TFVC and Git. I think because we want to use a distributed version control system, Git will be the better option for us.
Okay, so what about branching strategies? Because I hear they're pretty important.
Yeah, they are. There are various ones that we can use that are already available out there and have been proven to be quite good. For example, there is the Git flow and the GitHub flow.
Well, what's the main difference between those two? Because they sound pretty similar to me.
Well, the major difference between the two is that with the Git flow, you don't directly merge into the main branch unless it's a hotfix. With the GitHub workflow, there is not a development branch, so there are only feature branches and the main branch, and all the features get merged right into the main branch after, of course, they are tested successfully. And us devs have been using source control for many years now. So if we do something like pair programming between dev and ops, they can probably get used to it.
Peer programming?
No, pair programming. And this is where two people write the code together and they would literally sit next to each other. Now, I know that with the whole COVID situation, people work remote and they don't sit next to each other anymore, but working on the same code has within research has shown that it actually takes a bit longer to do. However, it means you end up with more stable code and people learn new coding practices better.
Wouldn't that mean there's a lot of overhead involved in that practice?
Well, like I said, it takes a bit longer to do, and it would probably be correct. There's about a 15% overhead involved. But that overhead is largely compensated by the increased quality of code, which means less bug fixes. And we know that bug fixes further along the development process, like in releasing to production, cost a lot of money and time. So, and at the end of it, there's other things we can do as well, like code reviews. And at the end of the day, we just have to figure out and experiment what would work best for us.
Okay, so what's to stop somebody coding their own release and pushing it straight to the main branch?
I'm glad you asked. So in Azure DevOps, we have something called branching policies that we can use. One of which is that two people can have to approve updates to the main branch.
That sounds good. I think we need to do that to be SOX compliant anyway, since we deal with financial data. So I'm just going to quickly go through and see if I can do that now. So, by the way, everybody, for those of you who've used Gitbike over the command line over the years, this is just basically a visual representation of your Git repository. And as you can see, it's basically a file store. And just like with the Git command line, you can view your files, your commits, your pushes, your branches that you have in place, tags, which is the same as using the Git tag command. So as you can see, we've got a data Saturday water tag and your pull requests as well. However, one of the things that you have to do to be SOX compliant is to have the full wide principle in place. And to do that, you need to click on the ellipsis and select branch policies. And then from there, we first have to set the minimum number of reviewers to 2. And in addition to that, just to make sure that a pull request is raised every time that somebody tries to merge into this particular branch, we have to automatically add reviewers. So for example, here, I would have to add Sander, and every time I want to do a pull request into this release, into this branch, Sander will effectively get an email. And that's how it's done.
Yeah. And these are the main points we want you to take away from this section is that the Azure DevOps supports multiple version control systems. However, Git has become de facto standard nowadays. In addition, you can secure your updates to your branches using branching policies like you've seen Kevin just demonstrate. And Git really hooks it nicely with other tools like Visual Studio and Azure Data Studio as well.
Okay, has anybody got any questions before we go into boards? Give this a second here. Okay, so we better discuss Azure Boards since I'm going to be using it to organize our backlog items. Now, Azure Boards can use basic Agile, Scrum, or CMMI templates for each project that you create in Azure DevOps. As I mentioned earlier when I covered the organization settings, these templates are actually called a process in Azure DevOps. Now, because we're using Scrum Sander, we'll probably want to use the Scrum process. For now, we can keep it as standard, but we can customize these processes if we need to. And just to give everyone a very quick introduction to Azure Boards, I'm just going to quickly go through the default services. So you have work items, which allows you to view your work items in a linear format. Personally, I think this is quite useful because you can find items that have been removed. You have boards, which allows you to show the boards in a Kanban kind of way. So if you've worked with Kanban or Scrumban in the past, you may find this particular view useful. Then you have the backlog view, which allows you to view all of your outstanding backlog items, which is very useful, especially if you are working using Scrum. And then talking of Scrum, you also have sprints, which allows you to view all of the backlog items that you're working on in your sprints all together, and also allows you to easily move around all your different tasks you're doing as part of the backlog item. And then finally, there's queries, which allows you to create powerful queries against all of your work items.
Cool. So I have a question, Kevin. How are the backlog items organized for Scrum?
Well, we go back up to the backlogs, I'll be able to show you here. So the hierarchy for Scrum in Azure Boards is that you have basically one or more epics, followed by one or more features, and then you can have one or more backlog items. So basically the hierarchy is epics, features, and then backlog items. Now, if we were to use the Agile template instead, it would actually be epic, feature, and then user stories instead. By the way, did I mention all the analytics and preview features we can actually potentially use to query against people?
Steady on, Kevin. We only have 60 minutes to do this, so we're probably not going to make that.
Okay. Well, I'll quickly, very quickly just say to everybody that if you look in analytics views, I still got that. You can actually populate all of these into Power BI data sets. I do actually have a blog post so you can actually replicate one of these for a sprint review, and normally you would demo this, but I have actually noticed the time of this myself at the moment. So I will give it a miss for now, and I will actually pass a link to the post over into the chat somehow in a minute. Anyway, the main thing to take away from this section, everyone, is that Azure Boards is a very powerful way of managing Scrum or Agile work visually, especially if you're a product owner.
Okay, let's talk about Azure Pipelines. This is where we will actually build and deploy our deliverables.
Okay, so how would this work with SQL Server?
Well, we could look to deploy either using state-based or migration-based deployments.
Well, what's the main difference between those two?
Well, there's a big difference. So state-based is more like the destination of your journey, where you will look at where it will look at the current state of your project and then look at the target and then compares the two and then just pushes all the changes to your target database. With migration based, it's more like the journey towards your destination. You start at one point and all the changes along the way will be new scripts which have to be applied incrementally instead. So, and migration, they're both good. Let me just be clear about that. Both have their purpose and both have their pros and cons. So, and that's an entire session on its own. With my migration based can be good, but in our situation, we probably want to go for state based because we don't have that many schema kind of changes. And it's fairly easy to do to build a pipeline for SQL Server, as I will demonstrate right now. So I'm going to share my screen. Share screen. First, I have to allow that.
Do I have to start sharing?
Oh, let me see how that works. Oh, that's it.
Let's see, because we can see in real time if it changes or not.
I just shared it, so you probably have to unshare it.
Right. You may have to share it again.
Let's do that. So share screen, share. There we go. Can you see my screen?
No, I can just see me and you right now.
Why isn't it working?
Are you setting it to share the whole screen, yeah?
Mm-hmm. Screen. Allow.
And then you should have another. Hey, something.
Oh, there it is. I had to change focus to the screen, so that was probably it. So, when I wanted to get all our databases in source control, what I found out is that it's a lot of work to create your solution and then maybe multiple projects. And I want to separate the data model from the unit tests. And that was a lot of work because we had like 40, 50 databases that I had to do. So that would take like a week to get it all completed. So what I did instead was I used the PS module development PowerShell module created by Friedrich Weinmann that enabled me to create a template of my entire solution. So I only had to do it once, and then I made it in a template, and now I can just use that template to create a SSDT solution. And this SSDT, that template is on my GitHub page, and I will demonstrate that right now. So what this will do, and this is the entire script, and it does a lot of stuff like downloading the latest template, and then extracting it and installing it. But the most important part of the entire script is this little command right here. And what this will do is it will run and use the template to create my SSDT solution. And this is how that looks like. Create my project.
It's worth noting while we're doing this, Sander, by the way, if anybody has trouble and they want to see the screen in more detail, put your mouse cursor over the window, and there is actually a little square button, square icon appears in the bottom right hand corner of your screen. If you click on that, it will expand the screen to be the full screen size for you. Sorry, Sander.
Oh, it's already pretty big, but so this took like something like less than 10 seconds. You wouldn't be able to do this manually. So this is my project or my solution with multiple projects. Let's open that in Visual Studio. Okay, there we are. So I have two projects within my solution. So what I have is a data project, which will only contain the data model, and one that only contains the unit tests. So what I can do is I already have a database, so I can go and select that one. This is going to be that one. Don't type in demos. That's never a good idea, but I'm going to try it anyway. So I created a really small database with some random objects. And I'm going to say just schema and start. Done. I have all my objects in here. I could have done something like a schema object, so it would have the store procedures in here, but it's your decision what you want to do. And because there's a reference in my unit tests project, I don't have to import the objects twice. So anything that's in here will also be in my unit testing project. And we can do unit testing in several different ways, but I like to use something like T-SQL-T to do these kind of things. So I can actually show you. Wait, before I show you anything like that, I am going to show you something else. So when you use this template, it also creates a Azure Pipelines YAML file for you. If I open that with Visual Studio Code, I can demonstrate. This will build your project. It will then open or spin up a SQL Server container for SQL Server 2017 and 2019, deploy the DAG pack to it, and then run all your tests if you have them. And then it will show the results in Azure DevOps as test results, so you don't have to create the entire pipeline yourself. It can just be done like this. So let me show you how the unit testing works. So I'm lazy as hell when it comes to repetitive tasks. So when I wanted to create the unit tests, I wanted to do something like a test if my tables there, is my store procedure there? Does my table have the correct columns with the correct data type? Does my store procedure have the correct parameters with the correct data type? Does my view have the correct columns? Does my table have all the correct indexes and foreign keys and all those kind of things? And when you think about those, you can end up with thousands of unit tests. So I wrote a PowerShell module called the PST-SQL-T Test Generator. This is a module that is freely available. It's on the PowerShell gallery. Just use install module and then the PST-SQL-T. And it's open source, so it's on GitHub as well. So you can even contribute if you want to. So if I run that, create the unit tests. It will connect to my database. And what it does is it will look at the current state of my database. And then it will take all the objects and then generate all the tests for it. Don't do this every single time for all the objects, because you will end up with successful tests every single time because it overwrites the previous ones. just do this once for all the objects, and only if you want to do some specific ones, select only the ones you want to generate. So it should almost be done. There we are. So I can go back to my project and go to my test basic. That's a folder that I always use for basic unit tests. Add an existing item, and because I selected a folder that directly is directly into my project, I can just select that. And now I have all the unit tests as well. So if I ever want to do a deployment, I have all the unit tests already in my project here. And just to show you a bit, something like the database collation, that's a pretty important test. Does my store procedure exist? These are really basic tests, and you probably have to do some more testing with more integration testing with your store procedures as well. So that was my demo for T-SQL-T.
And probably my cue to go off mute as well. So I've seen that we can either use GUI, tasks, or YAML for our pipelines. So which do you think we should use in Azure?
Well, GUI is good for exploring the pipelines, but YAML is easier to do. By the way, there's even a IntelliSense in Azure DevOps that helps you write all these things. And if you select an item from the marketplace into your YAML pipeline, you just fill in the values in that item, and then it's converted to YAML for you anyway.
That's good. Let me just share my screen a minute, because whilst you're talking and explaining about T-SQL-T, I actually did a bit of work myself. And hey, all my work. Let's hope I can share the screen properly in this application, and then we'll see. So I set it to be shared, but it's not appeared yet. So take 2, everybody.
Make sure you focus on, you click something in that screen.
That is actually why, because I think it's flicking between that and something else. Let's try again. I think it's telling me it's sharing my screen, but I can't see it yet.
Now click somewhere that you want to the screen you want to share.
I did do that. It's telling me it's sharing my screen, and it's not. So bear with me. I got a workaround for this. That's okay. Not it. You see, my screen is showing as shared, but for some reason I can only see you. If somebody else can't see my screen, can you please confirm it, either by text or Denny if you can in person? There you go.
There it is.
A bit of a delay. So apologies for the delay, everybody. Right, so like I said, I was experimenting whilst you were telling everybody about T-SQL-T. And before I carry on and show you exactly what I did, I thought, well, let's see it working. So I'm going to make a change to a column in a table here. So here's a definition for a table. And now that I've actually done that, I'm just going to commit the change. So I'm just going to change. And this is basically this is making the change to the local repository, a clone of the repository on my machine. So I'm now just going to sync.
By the way, you can also click down in the left corner next to main. There's you would see like a refresh thing button, and also refreshes it for you.
And I did actually test this earlier, so it's kind of... Anyway, So back to this. So once I've done that change, as you've seen, actually, I've synchronized it. So it's updated the repository here, Sander and Azure DevOps. So this is now being synced up with my change for the column, which has actually started the pipeline to be run. And if I dig into this pipeline for you, you can see at this moment in time, I kept your initial build and unit test stages, by the way, for this, but I kind of took it upon myself to take out the unit test for SQL Server 2017 because I wanted to deploy the SQL Server 2019. And if I zoom over to here and I just go to the top ones for now, and then it has a mind of its own inside to change its mind. So as you can see, I've got 3 SQL Server 2019 instances is currently deploying to that represent integration, staging, and production environments. So obviously integration, like you mentioned just now, is where you do your integration tests. Staging environment has various names, and that's where you tend to do user acceptance tests. And then, of course, you have your production environment, which is quite self-explanatory. And to represent these 3 different environments, these 3 instances are actually running in 3 separate Docker containers on my laptop. However, in reality, these instances could be on servers anywhere on your network for SQL Server installed. So I'd done that and tested, and that all worked fine. And I thought to myself, why stop there? So I quite ambitiously then decided to synchronize it with a GitHub repository as well. So basically, this Azure pipeline synchronizes the Git repository in Azure repos with an actual GitHub repository, and that in turn fires off a GitHub action to update yet another SQL Server database on the production instance. However, that GitHub action could obviously go off and do any number of things. And I thought after that, well, why stop there? So I tested and I thought I would look to see if I can convert the project so that it can be easily deployed to an Azure SQL database behind the scenes so that it works from the same repository. So basically doing it in the way that I've set it to do means you only have to keep 1 copy of this repository instead of multiple copies behind the scenes. And let me flip back to this now. And the way I did that is actually I did some PowerShell behind the scenes. Then all I literally did was change 1 line in the SQL project file before it went to convert to create the DAT pack. And then that DAT pack was prepared for that certain version of the SQL Server related database. And because it worked for Azure SQL database, I then went and tried it for an Azure Synapse Analytics dedicated SQL pool. And I do appreciate the fact that that is actually a bit of a mouthful. But effectively, I was able to deploy the same database and the same schema update, the same column change to SQL Server 2019 instances, an Azure SQL database, and an Azure Synapse Analytics dedicated SQL pool. And what I can actually do, I have the code open here, and I can show you how this actually looks. And I hope that everybody can see this. So basically, obviously you copy the files to staging area. This is the most important part for this build stage here. So this is the PowerShell that I used, Sander. So it literally just copied your repository to another subfolder. And then it changed that 1 line of code to represent the different target it was going to deploy to. Once that was done, I could build the project based on the changed SQL proj file and then publish it as a separate artifact, as you can see down here. And as you can see, these have all been completed. And these databases are scattered around in various places in Azure Data Studio, as you can see here, for example. And in addition to this as well, just to show that it does really, really work. As you remember, in Azure Data Studio, we changed it from column B to column A. As you can see, this still says column B. I click on refresh. You can see it's now changed to column A. No smoke and mirrors here. That is legitimately how it worked. So,
well, it's great that we can do the T-SQL-T tests on a database project that will end up on a dedicated SQL pool. It just takes a bit of imagination. Plus, you have to take the SQL pool schema into consideration as well.
Yeah. Normally, I would put this into the chat, but we seem to be a bit limited with what we can put in the chat at the moment.
Yeah.
So there is actually a website that explains to you the differences between a normal SQL Server database and an Azure Synapse Analytics dedicated SQL pool.
Okay.
So, like Sandra said, they have to take it in mind.
Yeah. And of course, for these kind of deployments, you can use PowerShell instead for your YAML to handle your deployments if you're dealing with a large number of servers.
How do we know if that worked?
Well, we could simply get PowerShell to output the XML into the same format as the JUnit test results, and then allow Azure DevOps to use the XML, which publishes test results, to view the results visually. Of course, we can put other feedback mechanisms in place as well.
We can do that?
Yeah, we can do that.
Oh, awesome. So if we go to edit a pipeline, just exactly like here and here that I did there, are we limited to all these tasks that we see on the right-hand side here?
No, in fact, you can install loads of additional extensions from the marketplace to add more tasks. Of course, because we are an enterprise company, we may have to request to install those instead of being able to install them straight away, which you usually do, which team manages your Azure DevOps. And we've seen in the past that some of these extensions are not thoroughly tested enough. So you will probably refrain from installing this without informing anybody else.
I honestly didn't realize that was a thing.
Oh, yeah. But it does mean we can get help with those security and compliance issues you were talking about earlier. Plus, if I get the feeling we have to install the Synapse Workspace deployment extension anyway, because I know you've already been asked, if possible, to redeploy Workspace artifacts to another one. From what you mentioned, you can do that, right?
Yeah, I can do that. Okay, so I've seen that we can use Microsoft hosted agents even within our own network on premises, which are servers Microsoft hosts in Azure to do a lot of the processing of the build and release tasks, like building various artifacts and deploying them. However, Sandra, it appears that because of our infrastructure, we would have a lot of issues internally. For example, we'd have to raise a lot of firewall requests. So maybe we are better off building our own agents internally.
Maybe, but remember, a lot of us are developers and we don't want to build our own servers. Plus, we'd have to figure out what the software to install on those agents and maintain them, right? Oh, that's cool.
Yeah, so for everybody here, basically, Microsoft actually provides you with a guide on how you can create your own images for Azure DevOps agents. However, the title may be a bit confusing for some of you because actually you use the same guide to create GitHub Action agents as well.
So, well, if we're going to do that, we might as well run the agent through the command line instead of using it as a service.
How come?
Well, now, everybody knows that when running something through the command line, you get more verbose results.
Okay, well, as you know, I tested this earlier. So let's see the results on the next slide.
And behold. Well, there's not much there, Kevin. Oh, next part. Test plans.
Move fairly quickly there.
Yeah, there's the bunch there. So, well, of course, we can do test plans once we've done the initial build and release before we release elsewhere.
Don't they all have to be automated though? Because that would take a lot of effort for some items.
Not necessarily. Your test plans can have manual steps as well, which you can. I think you can demonstrate that, right?
Oh yeah. Let's have a look and see if I can. So, if we go back in the Azure DevOps Center and look at test plans. Oh yeah, we actually have a test plan here. Well, actually, this is a test suite. So basically, Azure test plans, I like to think it is semi-structured. And why I think that is quite simple. Basically, in Azure test plans, you have test suites that can contain one or more test cases. And each of these test cases can contain one or more test plans. However, the test suites themselves can actually just contain the actual test plans, just like you can see here. And that's why I like to think of it as being semi-structured. So here you can see you can actually define your test, and then you have another tab where you can execute it. So if I click to execute it and select Run for Web Application, you can see I get a little pop-up up here. And I will just make it a bit bigger for everybody here. And basically, the idea is you would go through all of these steps one by one and tick them off if they're right. And as you can see, you can actually insert pictures here. So, for example, you want to check that the pipeline's being deployed correctly. And if there's a problem, I can click on the cross and I can say, for example, it broke. Very long, detailed explanation there. And if I click on create bug after finding a bug, for example, it actually goes up to start creating the bug for me. And if you scroll down, you can actually see it's got my comment in there about the fact it's broke. Just discard those changes briefly. There's other things you can do in these test plans as well. You can take a snapshot of a screen. You can also capture a certain image if you want to. You can record your actions. And you can also record your actions with audio if you want to provide audio commentary for one reason or another. Now, there is actually a desktop version of this web application you can install yourselves on your computer. Of course, if you've got a corporate machine, there may be a slight issue with getting the permission for the application to be installed. And another thing to think about is that by default, the actual application opens up in your main monitor. So if you have multiple monitors connected to your computer, it's going to open up on your main one, and you may need to change your main monitor settings to get it to open in a relevant place for you. So
cool.
That was a very brief introduction to Azure Test Plans. And of course, you've got other features here that go with it, like your progress report, parameter settings, changing the various configurations, etc.
So we better briefly discuss artifacts here, which is where you can share various things like NuGet packages with others. For example, if you create a NuGet package, you can share it within Azure Artifacts for others to use. To help remove some jargon for you, a feed is basically a source that people can access to download packages, which can be online somewhere or somewhere on your network. For you Linux people, it's basically a repository. And these feeds can be configured to host various types of packages, including NuGet, NPM, Maven, Python, and universal packages as well.
Yeah, indeed. So you can create what's known as a universal package, which I will actually demo now because it's quite interesting. And something tells me that Sander may have a bit of a smile on his face appear in a minute. So, as you can see, here is an artifact we created earlier, and it's got a package in there called DBA Tools, strangely enough. Interesting coincidence there. So, if you click on the actual DBA Tools package that has been installed, you can actually get the command to download the said package. So, what I can actually do here, I've actually copied it into a PowerShell font. And the only thing I've changed, I've just set a path there called DBA Tools. So all I have to do is run this command, and it will download DBA Tools locally onto my laptop for use. Now, whilst just doing that, I will explain a few things right now to make things easier for everybody. So, Universal package, according to Microsoft, has been tested for packages up to 1 terabyte in size, and it's recommended for large binary files. However, as you can see here, we've used it for the DBA Tools PowerShell module. Now, at this moment in time, there appears to be a slight issue with publishing artifacts, basically uploading your own packages into this feed using your own account. So, for example, a@b.com, there are some slight issues, apparently. So what I do recommend doing at the moment, if you are going to use this to upload packages into your artifacts, is actually log into the Azure CLI using a PAT token instead of your own Azure account. That way you will not have the issues that people seem to be having at this particular moment in time. Now, hopefully now I can, yeah, as you can see, it's actually completed. So there you go. So I've got a copy of the DBA Tools PowerShell module onto my machine. And in reality, you can actually use these artifacts as part of Azure pipelines. So for example, I could download artifacts into the actual SQL servers that you saw earlier, and you can do the same yourself. So if for some reason you needed, like here, to install a DBA Tools PowerShell module onto a particular server, and you wanted to do it by a pipeline, you're more than capable of doing so. And of course, anything else up to 1 terabyte in size as well, which is why it's called a universal package. And I'm kind of guessing that Sander really appreciates this option.
That creates some possibilities.
So, to be honest, there are other features in Azure DevOps I'm looking forward to the team using as well, Sander. So, if I flip back into Azure DevOps yet again for everybody. So, there's various dashboards that we can configure as well. And from what I can gather, the more extensions that we install, like what you were talking about earlier, the more that we can actually use towards all these different dashboards. As you can see, there's a Sprint Go extension installed. So it allows us to show a Sprint Go. So if you have a daily stand-up every day, for example, and you want to use a dashboard, you can open one up to remind all of the team what the Sprint Go actually is. So this can be very good visual aid. There's a few other things on here.
Don't forget the wiki. That is an important one.
It is indeed. So you actually do get your own wiki as well that you can use within Azure DevOps. I've already talked about the analytics views, which we can actually populate all of those straight into Power BI. And in fact, you can actually use these analytics views for Power BI dashboards, and then over time, because I get the feeling that some engineers may be keen to edit Power BI dashboards in a very different way in Azure itself, they can actually look to edit them in Synapse Studio instead of having the desktop installed on their workstations if they want to. By the way, Sander, there's also an extension for the Azure CLI that you can install as well. to do a lot of commands for Azure DevOps. However, at this moment in time, a lot of the commands are in preview. And
okay. Go ahead.
I thought you might like that since you like doing the fun stuff. And also, one final thing is well, not final at all, but I want to remember as well that everybody is eligible to create their own Azure DevOps organization that tests things on. And if you have if they have official Studio subscriptions as well, that can bring in additional benefits. Even more so if you start sharing your own personal Azure DevOps organization with somebody else that's got official Studio subscription, then you can take advantage of a lot more there as well. And obviously, when I mean organization, I mean these organizations on the left-hand side. Just like, as you can see here, I can create a new one myself.
And this is just in case you want to test out things without the fear of breaking anything in your organization or your company's Azure Ruby and DevOps organization. So, knowing all this, Kevin, where shall we begin?
Well, I suggest we start by getting both teams together and explain to them what we're trying to achieve, because it's very important when you start to do something like this to get everybody on board.
Yeah, you're correct. Anyway, this is all we've got time for today, folks. And I'm wondering if we have any questions. I'm looking at the comments, but I don't see anything.
Neither do I at this moment in time. So,
it's very silent. Either it's a really complex question. They're still typing.
Or somebody is. What I will do.
So it was a very nice session, very interesting session about DevOps and database DevOps. And
Thank you.
Joseph liked it as well. Joseph is saying that it was very nice as well.
Okay. Thanks, Joseph.
Hi.
So thank you very much for your session. It was a great presentation about the DevOps, and it was a pleasure to have both of you here at the conference. Thank you.
Thank you for having us.
Yeah, thank you. So if anybody has got any questions, of course, feel free to reach out to myself or Sander. What I should probably actually start doing, because there's a fair few slides and photos of this session, and I've had to do it a few times now, is actually put our contact things at the end as well, ongoing. So what I will very quickly do now, actually, and to save anybody actually having to watch me go through all the slides again. So, as I was saying, thank you very much, everybody, for watching this session anyway. And whilst you're wondering whether or not you have any questions, I'm just going to share our details again in case you need to reach out to either of us. That's for Sander, and obviously on his GitHub is where you can find that his PowerShell modules he was talking about earlier. I do understand his T-SQL T1 is quite popular. And of course, there's mine if you need to reach me for anything as well.
Okay. Well, I think that's it.
Thank you very much.
Thanks.
Okay.
Bye.
Have a good. Bye-bye.
Bye. Have a good evening.
Have a good evening. Bye-bye.
Bye.
So now, according to the schedule, it's time for the dinner. It's time for the dinner break. So, but we made a small change on the schedule. According to the schedule now, it would be the quiz and the first challenge during the dinner break. But we decided to join the two quiz and make only one challenge that will give a prize for the first place and the second place. And this challenge will start at 9 p.m. So during this time, I will pair some videos for you on this channel on track 2. And it's on this track that the challenge will start at 9 p.m. So we will have a break for everyone, relax a bit, have a dinner, have a good dinner, take coffee, and we continue at 9 p.m. with the challenge of the quiz and offering 2 prizes for the winners. And you have the entire explanation about details of the conference on the Eventbrite page. For example, just a few minutes ago, I just published the treasure hunt of our conference. Yes, that's it. I was in doubt if I would be able to publish in time the treasure hunt, and it's published. What's that? What's the treasure hunt? The point is, we hide many free ebooks in a Google Maps of Malta. So you need to investigate the Google Maps of Malta, discover interesting places in Malta, and you'll find many free ebooks to download inside the Google Maps. And all this information is on Eventbrite. In fact, it's on Twitter. I just tweeted the information and I will include on Eventbrite on the session page as well. So, meanwhile, I will pair some videos for you until 9 p.m. when we get back for a fun and very interesting competition, giving prizes for the 2 first places of the competition. So let me start sharing some videos here.
Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now.
This is Quantum Impact, a brand new series all about quantum computing.
Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now. These solutions will help nurture our planet and improve our lives for generations to come. I'm Dr. Krista Savori, General Manager of Quantum Systems and Software at Microsoft.
And I'm Dr. Julie Love, Senior Director of Quantum Business Development. Krista and I will be your ambassadors to the world of quantum, where the field is today, what the future holds, and how people are using quantum solutions to address some of the world's toughest challenges. This is Quantum Impact.
In this series, Julie and I will be speaking with researchers, educators, students, and industry leaders from various fields to learn how they are already seeing a difference with quantum solutions. But first, let's unpack quantum computing.
Quantum computing applies the properties of quantum physics to the processing of information. A quantum computer is built with quantum bits, or qubits, whereas a bit in a classical computer holds a binary value of 0 or 1. A qubit can hold a combination of both values. When we use more bits in a classical computer, the compute power grows linearly with the number of bits. With qubits, every time we add a qubit to the quantum computer, the amount of information we can compute with doubles, and so the processing power grows exponentially. We use the wave-like nature of quantum particles to compute in superposition, processing multiple values simultaneously and taking advantage of quantum interference. By deepening our understanding of how quantum computers solve intractable problems, we've made breakthroughs that enable quantum solutions to run on classical hardware, yielding immediate advantages. And what's exciting is that those solutions will be even faster when run on full-scale quantum computers.
This exponentially faster and more powerful computing will accelerate the development of new sustainable materials, improved healthcare, methods to address food production, and combat climate change.
At Microsoft Quantum, we are building the quantum future and empowering people, developers, and organizations to experience quantum impact today.
Together with a global quantum community, we're building a scalable quantum system and ecosystem. We're designing a revolutionary topological qubit. We've made breakthroughs in cryogenic engineering, open sourced our quantum development kit and programming language Q#, and we've introduced a full stack open cloud ecosystem with Azure Quantum, bringing forward quantum solutions, software, and hardware for everyone to learn, build, and solve with quantum today.
These advances are bringing the promise of quantum to our world right now, and we're seeing the results take shape.
Join us as we tackle big issues in chemistry, healthcare, environmental science, and education, uncovering how quantum is being used today and will be used tomorrow to change our world.
Environmental challenges today represent one of our most existential challenges yet.
Land use optimization is this problem that classical computing isn't perfectly poised to solve.
For many of us, quantum computing seems like a relatively new concept. But the reality is that quantum computing has existed for billions of years. Nature is our most powerful quantum computer. At its core, nature operates on a quantum scale and behaves according to the rules of quantum mechanics, a system that governs our world. With quantum computing, we are now harnessing this behavior of the natural world to unlock better environmental solutions to help secure our future. I'm Julie Love, Senior Director of Quantum Business Development at Microsoft. And today, I'm meeting with Lucas Joppa, Microsoft's Chief Environmental Officer, to talk about the complex environmental challenges we're facing today.
We are at the beautiful Oxbow Farms. I thought this would be a super contextual spot for us to talk a little bit about the intersection of environmental challenges and computing.
I've been really excited about our partnership. We have this shared passion for the environment. How can we deploy quantum technologies to help with climate change? What are the issues that you see the world facing?
Environmental challenges today represent, as a human society, one of our most existential challenges yet. We somehow have to figure out how to mitigate and adapt to changing climates, ensure resilient water supplies, somehow sustainably feed a human population growing to 10 billion people, all while stemming an ongoing and catastrophic loss of biodiversity. And we can't do any of those things independently. They have to be done together.
Well, those four big pillars also are in conflict with each other as well. And you had a lot of work going on in land use optimization where we can deploy these quantum techniques to solve this vast array of variables that we need to optimize. And simply having local optimizations is not going to cut it at the scale of the Earth.
That's right. Earth is a big place and there's a lot going on. You can break the Earth into every square meter of land and water. And for every place on Earth, there's many different things that we could use that land or water for. We could use it for protection, for growing food, for sequestering carbon from the atmosphere, for putting houses for people to live. It's all about how we can help people make better choices so that we can minimize our impact on the planet and the planet can maximize its contributions to human society.
If it's done globally, proper land use optimization will allow us to produce enough food for the world's population while still protecting our communities, our water supply, and animal habitats. To solve optimization problems today, we use new quantum solutions deployed on classical hardware. These algorithms sift through a vast number of possibilities to find an optimal outcome. And they can also scale to the quantum computers of tomorrow, harnessing the full power of quantum to solve tougher problems, like the land use challenges here at Oxbow.
Some of them aren't quite ready.
Oxbow a bit more and grow a little bit longer in the season. But doing that, we open ourselves up to some of the negative repercussions that can come about from agriculture. Erosion in a flood event, runoff that hinder the salmon that spawn in the river, things like that. Right now we're growing on 15 acres of land, but we manage 30. We rotate through those 30 acres in a way that allows us to make the money that we need to as a farm, but also contribute to soil health. The whole mission and focus of what we do is to grow organic food, but do it in a way that's low impact on the environment and actually beneficial to the lands on which we're farming.
I think it's amazing as you're considering not only your land and your business, but the environment around us, which is not always top of mind.
It definitely isn't. But I think it's something that we're becoming more conscious of. Because of that, as we look at the way we use our land, we try to recognize that the impact we have on that land will impact our community as well.
Decisions that Oxbow is making showcases all of the different land use decisions that people have to make everywhere.
All of it's part of this global system. And literally, we need to do a global optimization of this problem. We have thousands of variables that are highly interacting. This becomes a vastly exponential search space. And with quantum computers, we can explore that space in a really different way that's not possible with classical computers.
What excites me about quantum computing is this ability to exist in many states at once and to explore many different scenarios. It just seems like a perfect computing architecture to combine with what I think to be one of the world's biggest optimization challenges.
Being at Oxbow with Lucas was a great opportunity to see how these complex land use problems are being solved today. Quantum solutions for optimization will play a pivotal role in helping farmers and land managers make more globally informed decisions that will not only contribute to the overall health of our world, but also lead us into a more sustainable future.
For my own students that are, hard at work in the research laboratory, they can see something that is totally contrary to what they've observed before. That was amazing because it's very rare that you learn something as crazy as quantum mechanics and then learn that it could be used for new technologies. Education is an important foundation for helping advance a new field, especially in science and technology. Major universities will play a key role in developing the next generation of quantum programmers, scientists, engineers, and researchers. A great place to learn about how universities are advancing quantum knowledge is the University of Washington, one of our partners in the Northwest Quantum Nexus and home of the Quantum X initiative. I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. And today, I'm meeting with Professor Kai-Mei Fu, an experimental physics researcher and professor focusing on advancing quantum technologies. Kai-Mei, thank you for speaking with me today about quantum information science. Would you tell me a little bit about your role here at the University of Washington?
I'm a professor in the physics department and the electrical and computer engineering department. I teach from first year physics all the way to graduate level courses in quantum information, but then I also run a laboratory developing hardware for quantum information science. This is science and technology where you utilize quantum mechanics to achieve a technological or scientific advantage. We generally split it up into 4 categories. One is quantum computing, algorithms that use entanglement, superposition for a computational advantage, communication. By the laws of quantum mechanics, you can't copy a state. And so that means you can have secure communication. Sensing, we can have very, very high precision sensors that exist in quantum mechanical states. And finally, it's simulation. We want to be able to simulate the world around us, but many of the interesting materials that we have quantum mechanical interactions that we can't simulate on a classical computer.
For myself, I remember taking a cryptography seminar. I was a math major as an undergraduate, and when I took that seminar, I learned that there was a model of computation, namely quantum computing, that could break, most of our public key crypto systems today, right? The mainstay of e-commerce today, RSA. I was perplexed, fascinated, and inspired, all at the same time. And I actually then switched into computer science because I wanted to be able to take that model of computation and make it programmable and, enable users to actually program a quantum computer to solve such problems. So it's pretty exciting to see this emerge, and the numbers of jobs getting posted is growing quite rapidly.
LinkedIn said that in the past year and a half, the number of postings in this area has gone up 180% as compared to the prior 3 to 4 years. So significant growth in this area right now.
So you must see more and more students expressing interest in quantum information science.
When I first came here, I would get a few students a year asking to work in my laboratory at the undergraduate level, and now I get several students every week, and my lab can't possibly have that many researchers.
Talking with Professor Fu reinforces that there's a ton of opportunity and diversity of skills required in the field of quantum information sciences. I wanted to hear from some University of Washington students to understand their experiences and research and what inspired them to pursue a career in quantum.
I did double major with math and physics in my undergrad, and then slowly realized that everything I liked about math was actually physics.
My road into quantum information was a little non-linear.
So I was just exploring different fields, and I tried a little bit of synthetic biology.
One day I was working on some homework in one of the upstairs study rooms, and a grad student came up and asked if anybody wanted to see something amazing. He'd just gotten his experiments work looking at fluorescent molecules in live cells. You could actually watch these molecules moving around. It was just an incredible moment of, I was seeing something that maybe 50 people had ever seen before, and I joined their lab the next week.
So your research here at the University of Washington, what is it about? What are you focused on?
My research is in discovering whether we can use quantum devices to aid in the calculations relevant for nuclear and particle physics.
I am an ion trapper. So I trap single barium ions and then use them to study quantum mechanics.
Working with nitrogen vacancy defects in diamond, we have these isolated single atom like defects in this diamond, and we use them as a qubits in a quantum computation system. The future quantum computation holds a lot of promise. Quantum communication also, it's the start of something great. So I want to be part of it.
So as a viewer at home, what's your recommendation to really start learning about this exciting field of quantum information?
Be curious. I mean, that's really what I want to say. Be curious, learn what you can learn now, learn how, learn about light, how light diffracts through crystals, do experiments. And of course, have a solid foundation in mathematics. That's probably all you need for entering this field.
I always think back to my own experience. I never took physics until my graduate school days when I jumped straight into quantum mechanics without classical mechanics. And there are also opportunities to pick up and start learning quantum programming today, right? With Q# and the Microsoft Quantum Development Kit. You can try little exercises in quantum programming and start to actually, be introduced to some of the concepts of quantum mechanics in a way that may be more familiar to one that, codes daily, right?
Yeah, and you can even have access to quantum simulators and quantum computers through the cloud right now that are publicly accessible that people can play on, which is something that just didn't exist 5 years ago.
Well, thank you so much, Kaimei, for speaking with me today about this really exciting field.
Well, it was my pleasure to be here.
The University of Washington is focusing on educating students to be able to jump into the quantum information sciences. And programs are popping up at universities around the world, full of students ready to push the field forward. It's through these curious and dedicated students that the next breakthroughs and innovations in quantum will come. And I, for one, can't wait to see what they accomplish. Chemistry. It helps make up our world, and yet there are still huge gaps in our understanding of it.
Converting chemicals from one form to another requires very accurate calculations. We see catalysis as one of the killer apps for quantum computing.
What solutions could we develop if we were able to model more complex molecules and reactions on a scalable quantum computer?
Converting chemicals from one form to another, understanding that requires very high level, very accurate calculations so you can make predictions about how the chemical reactions will work. We see catalysis as one of the killer apps for quantum computing.
Chemistry. It helps make up our world. And yet there are still huge gaps in our understanding of it. Our most powerful classical computers are limited in the chemical modeling they can perform, and in turn, the solutions they can unlock. What solutions could we develop, for example, to address sustainability if we were able to model more complex molecules and reactions efficiently? And what if we are able to do that on a scalable quantum computer? I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. Today, I'm traveling to Richland, Washington to meet with Nathan Baker at Pacific Northwest National Laboratory, where we've been partnering to bring the power of quantum to our understanding of chemistry.
Pacific Northwest National Lab, or PNNL as we call it, is a Department of Energy national lab. These laboratories handle large, complex problems of national interest. First and foremost, PNNL is interested in some of the deep problems associated with chemistry. We've been very focused on problems in catalysis. So that is converting chemicals from one form to another. The science of catalysis is trying to understand how that works and use that chemical knowledge to be able to design better ways to carry out that conversion.
So with catalysis, we really want to improve that efficiency and have less dependence on our natural resources.
That's right. Quantum chemistry is the area of computational chemistry that tries to understand how molecules react with one another, what their energies are, and how atoms move around in a chemical reaction. The problem is the level of accuracy we would need to design a new catalyst is something that even the largest computers today are struggling to realize.
Like those behind us.
Like the ones behind us. The excitement around quantum computing is that rather than waiting for a computer that's 1 billion times more powerful than the one behind us, quantum computing could help us get to that accuracy sooner. And with finite resources, working hand in hand with the classical computing techniques that we already have and use every day.
Putting it simply, nature speaks the language of quantum mechanics, and we're now striving to build computers that can do the same. When our technology is built on the same foundational principles as nature, we'll be able to mimic its behavior and harness that power to make an impact on the world around us. Here's an example. Over 100 years ago, the process that allows us to industrially convert nitrogen to ammonia was developed. This process has been critical to artificial fertilizer production, and in turn, has enabled us to produce enough food for a global population of 7 billion. But the process is incredibly resource intensive, consuming large amounts of our world's precious resources, like natural gas. We want to improve this process for the sake of our environment. To explore this chemical behavior in depth, I'm speaking with Bojana Janowska, a computational chemist here at PNNL, about her work with nitrogenase, an enzyme present in healthy soils.
Well, I have been a computational chemist for quite a few years here at PNNL. My work focuses mostly on studying biological systems, that's enzymes, to study chemical reactions that are relevant to energy applications. One of the enzymes we're studying is nitrogenase. Fertilizers, and specifically ammonia that's used in fertilizers, is a very energy-intensive reaction. It actually uses about 1% of all the energy produced in the world just to convert nitrogen to ammonia. The bacteria that have this enzyme nitrogenase are able to really interconvert this reaction a lot more efficiently under very mild conditions. Nitrogen is very abundant. It's all around us. So we'd love to be able to take that nitrogen, turn it into ammonia, and have our agriculture really feed the world in a way that doesn't really deplete our energy resources. nature does it best. We've known that for quite some time, and we're trying really hard to understand all the mechanistic details so that we can build whatever it is that we need to put it into a technology.
That's a great phrase to build on, right? With quantum computing, I think we have the opportunity to now compute closer to how nature computes.
Exactly. We have made a lot of progress using classical computers, but we are constantly hitting against the limitations. Having the power of quantum computing would help us move this field very, very far ahead.
We have deep expertise in computational chemistry. What we don't have is the ability to understand how to put that onto a future quantum computing platform. And so it's been a great partnership. We've been able to use the tools, the languages that are coming out of Microsoft to turn these quantum chemistry capabilities into something that we hope will execute on the next generation of computers.
Yeah, it's great to bring together experts from both sides. These quantum algorithms can actually have impact and change solutions. That's pretty exciting. It's through these cross-industry partnerships that we're truly able to explore the full impact quantum computing can have on our world. Together with PNNL, we're working to develop quantum algorithms to enable better solutions to challenging problems in chemistry. And these quantum algorithms will one day run on a fully scaled quantum computer. When we join together to share knowledge across disciplines, we have an opportunity to revolutionize fields and unlock amazing capabilities to help save our planet. Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now.
This is Quantum Impact, a brand new series all about quantum computing.
Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now. These solutions will help nurture our planet and improve our lives for generations to come. I'm Dr. Krista Sabori, General Manager of Quantum Systems and Software at Microsoft.
And I'm Dr. Julie Love, Senior Director of Quantum Business Development. Krista and I will be your ambassadors to the world of quantum, where the field is today, what the future holds, and how people are using quantum solutions to address some of the world's toughest challenges. This is Quantum Impact.
In this series, Julie and I will be speaking with researchers, educators, students, and industry leaders from various fields to learn how they are already seeing a difference with quantum solutions. But first, let's unpack quantum computing.
Quantum computing applies the properties of quantum physics to the processing of information. A quantum computer is built with quantum bits, or qubits, whereas a bit in a classical computer holds a binary value of 0 or 1. A qubit can hold a combination of both values. When we use more bits in a classical computer, the compute power grows linearly with the number of bits. With qubits, every time we add a qubit to the quantum computer, the amount of information we can compute with doubles, and so the processing power grows exponentially. We use the wave-like nature of quantum particles to compute in superposition, processing multiple values simultaneously and taking advantage of quantum interference. By deepening our understanding of how quantum computers solve intractable problems, we've made breakthroughs that enable quantum solutions to run on classical hardware, yielding immediate advantages. And what's exciting is that those solutions will be even faster when run on full-scale quantum computers.
This exponentially faster and more powerful computing will accelerate the development of new sustainable materials, improved healthcare, methods to address food production, and combat climate change.
At Microsoft Quantum, we are building the quantum future and empowering people, developers, and organizations to experience quantum impact today.
Together with a global quantum community, we're building a scalable quantum system and ecosystem. We're designing a revolutionary topological qubit. We've made breakthroughs in cryogenic engineering, open sourced our quantum development kit and programming language Q#, and we've introduced a full stack open cloud ecosystem with Azure Quantum, bringing forward quantum solutions, software, and hardware for everyone to learn, build, and solve with quantum today.
These advances are bringing the promise of quantum to our world right now, and we're seeing the results take shape.
Join us as we tackle big issues in chemistry, healthcare, environmental science, and education, uncovering how quantum is being used today and will be used tomorrow to change our world.
Environmental challenges today represent one of our most existential challenges yet.
Land use optimization is this problem that classical computing isn't perfectly poised to solve.
For many of us, quantum computing seems like a relatively new concept. But the reality is that quantum computing has existed for billions of years. Nature is our most powerful quantum computer. At its core, nature operates on a quantum scale and behaves according to the rules of quantum mechanics, a system that governs our world. With quantum computing, we are now harnessing this behavior of the natural world to unlock better environmental solutions to help secure our future. I'm Julie Love, Senior Director of Quantum Business Development at Microsoft. And today, I'm meeting with Lucas Joppa, Microsoft's Chief Environmental Officer, to talk about the complex environmental challenges we're facing today.
We are at the beautiful Oxbow Farms. I thought this would be a super contextual spot for us to talk a little bit about the intersection of environmental challenges and computing.
I've been really excited about our partnership. We have this shared passion for the environment. How can we deploy quantum technologies to help with climate change? What are the issues that you see the world facing?
Environmental challenges today represent, as a human society, one of our most existential challenges yet. We somehow have to figure out how to mitigate and adapt to changing climates, ensure resilient water supplies, somehow sustainably feed a human population growing to 10 billion people, all while stemming an ongoing and catastrophic loss of biodiversity. And we can't do any of those things independently. They have to be done together.
Well, those four big pillars also are in conflict with each other as well. And you had a lot of work going on in land use optimization, where we can deploy these quantum techniques to solve this vast array of variables that we need to optimize. And simply having local optimizations is not going to cut it at the scale of the Earth.
That's right. Earth is a big place, and there's a lot going on. You can bring the Earth into every square meter of land and water. And for every place on Earth, there's many different things that we could use that land or water for. We could use it for protection, for growing food, for sequestering carbon from the atmosphere, for putting houses for people to live. It's all about how we can help people make better choices so that we can minimize our impact on the planet, and the planet can maximize its contributions to human society.
If it's done globally, proper land use optimization will allow us to produce enough food for the world's population while still protecting our communities, our water supply, and animal habitats. To solve optimization problems today, we use new quantum solutions deployed on classical hardware. These algorithms sift through a vast number of possibilities to find an optimal outcome. And they can also scale to the quantum computers of tomorrow, harnessing the full power of quantum to solve tougher problems, like the land use challenges here at Oxbow.
Oxbow as a whole is 250 acres. Being situated on such a large amount of land, it's easy to think, maybe I should grow a little bit more and grow a little bit longer in the season. But doing that, we open ourselves up to some of the negative repercussions that can come about from agriculture. Erosion in a flood event, runoff that hinder the salmon that spawn in the river, things like that. Right now, we're growing on 15 acres of land, but we manage 30. We rotate through those 30 acres in a way that allows us to make the money that we need to as a farm, but also contribute to soil health. The whole mission and focus of what we do is to grow organic food, but do it in a way that's low impact on the environment and actually beneficial to the lands on which we're farming.
I think it's amazing as you're considering not only your land and your business, but the environment around us, which is not always top of mind.
It definitely isn't. But I think it's something that we're becoming more conscious of. Because of that, as we look at the way we use our land, we try to recognize that the impact we have on that land will impact our community as well.
Decisions that Oxbow is making showcases all of the different land use decisions that people have to make everywhere.
All of it's part of this global system, and literally we need to do a global optimization of this problem. We have thousands of variables that are highly interacting. This becomes a vastly exponential search space, and with quantum computers we can explore that space in a really different way that's not possible with classical computers.
What excites me about quantum computing is this ability to exist in many states at once and to explore many different scenarios. It just seems like a perfect computing architecture to combine with what I think to be one of the world's biggest optimization challenges.
Being at Oxbow with Lucas was a great opportunity to see how these complex land use problems are being solved today. Quantum solutions for optimization will play a pivotal role in helping farmers and land managers make more globally informed decisions that will not only contribute to the overall health of our world,
crazy as quantum mechanics and then learn that it could be used for new technologies.
Education is an important foundation for helping advance a new field, especially in science and technology. Major universities will play a key role in developing the next generation of quantum programmers, scientists, engineers, and researchers. A great place to learn about how universities are advancing quantum knowledge is the University of Washington, one of our partners in the Northwest Quantum Nexus and home of the Quantum X initiative. I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. And today, I'm meeting with Professor Kai-Mei Fu, an experimental physics researcher and professor focusing on advancing quantum technologies. Kai-Mei, thank you for speaking with me today about quantum information science. Would you tell me a little bit about your role here at the University of Washington?
I'm a professor in the physics department and the electrical and computer engineering department. I teach from first year physics all the way to graduate level courses in quantum information, but then I also run a laboratory developing hardware for quantum information science. This is science and technology where you utilize quantum mechanics to achieve a technological or scientific advantage. We generally split it up into 4 categories. One is quantum computing, algorithms that use entanglement, superposition for a computational advantage. Communication, by the laws of quantum mechanics, you can't copy a state. And so that means you can have secure communication. Sensing, we can have very, very high precision sensors that exist in quantum mechanical states. And finally, it's simulation. We want to be able to simulate the world around us, but many of the interesting materials that we have quantum mechanical interactions that we can't simulate on a classical computer.
You know, for myself, I remember taking a cryptography seminar. I was a math major as an undergraduate, and when I took that seminar, I learned that there was a model of computation, namely quantum computing, that could break, most of our public key crypto systems today, right? The mainstay of e-commerce today, RSA. I was perplexed, fascinated, and inspired, all at the same time. And I actually then switched into computer science because I wanted to be able to take that model of computation and make it programmable and, enable users to actually program a quantum computer to solve such problems. So it's pretty exciting to see this emerge, and the numbers of jobs getting posted is growing quite rapidly.
LinkedIn said that in the past year and a half, the number of postings in this area has gone up 180% as compared to the prior 3 to 4 years. So significant growth in this area right now.
So you must see more and more students expressing interest in quantum information science.
When I first came here, I would get a few students a year asking to work in my laboratory at the undergraduate level, and now I get several students every week, and my lab can't possibly have that many researchers.
Talking with Professor Fu reinforces that there's a ton of opportunity and diversity of skills required in the field of quantum information sciences. I wanted to hear from some University of Washington students to understand their experiences and research and what inspired them to pursue a career in quantum.
I did double major with math and physics in my undergrad, and then slowly realized that everything I liked about math was actually physics.
My road into quantum information was a little non-linear.
I was just exploring different fields, and I tried a little bit of synthetic biology.
One day I was working on some homework in one of the upstairs study rooms, and a grad student came up and asked if anybody wanted to see something amazing. He'd just gotten his experiment to work looking at fluorescent molecules in live cells. You could actually watch these molecules moving around. It was just an incredible moment of I was seeing something that maybe 50 people had ever seen before, and I joined their lab the next week.
So your research here at the University of Washington, what is it about? What are you focused on?
My research is in discovering whether we can use quantum devices to aid in the calculations relevant for nuclear and particle physics.
I am an ion trapper. So I trap single barium ions and then use them to study quantum mechanics.
Working with nitrogen vacancy defects in diamond. We have these isolated single atom like defects in this diamond, and we use them as a qubits in a quantum computation system. The future quantum computation holds a lot of promise. Quantum communication also, it's the start of something great. So I want to be part of it.
So as a viewer at home, what's your recommendation to really start learning about this exciting field of quantum information?
Be curious. I mean, that's really what I want to say. Be curious, learn what you can learn now, learn how, learn about light, how light diffracts through crystals, do experiments. And of course, have a solid foundation in mathematics. That's probably all you need for entering this field.
I always think back to my own experience. I never took physics until my graduate school days when I jumped straight into quantum mechanics without classical mechanics. And there are also opportunities to pick up and start learning quantum programming today, right? With Q-Sharp and the Microsoft Quantum Development Kit. You can try little exercises in quantum programming and start to actually, be introduced to some of the concepts of quantum mechanics in a way that may be more familiar to one that, codes daily, right?
Yeah, and you can even have access to quantum simulators and quantum computers through the cloud right now that are publicly accessible that people can play on, which is something that just didn't exist 5 years ago.
Well, thank you so much, Kaimei, for speaking with me today about this really exciting field.
Well, it was my pleasure to be here.
The University of Washington is focusing on educating students to be able to jump into the quantum information sciences. And programs are popping up at universities around the world, full of students ready to push the field forward. It's through these curious and dedicated students that the next breakthroughs and innovations in quantum will come. And I, for one, can't wait to see what they accomplish. Chemistry. It helps make up our world, and yet there are still huge gaps in our understanding of it.
Converting chemicals from one form to another requires very accurate calculations. We see catalysis as one of the killer apps for quantum computing.
What solutions could we develop if we were able to model more complex molecules and reactions on a scalable quantum computer?
Converting chemicals from one form to another, understanding that requires very high level, very accurate calculations so you can make predictions about how the chemical reactions will work. We see catalysis as one of the killer apps for quantum computing.
Chemistry. It helps make up our world. And yet there are still huge gaps in our understanding of it. Our most powerful classical computers are limited in the chemical modeling they can perform, and in turn, the solutions they can unlock. What solutions could we develop, for example, to address sustainability if we were able to model more complex molecules and reactions efficiently? And what if we are able to do that on a scalable quantum computer? I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. Today, I'm traveling to Richland, Washington to meet with Nathan Baker at Pacific Northwest National Laboratory, where we've been partnering to bring the power of quantum to our understanding of chemistry.
Pacific Northwest National Lab, or PNNL as we call it, is a Department of Energy national lab. These laboratories handle large, complex problems of national interest. First and foremost, PNNL is interested in some of the deep problems associated with chemistry. We've been very focused on problems in catalysis. So that is converting chemicals from one form to another. The science of catalysis is trying to understand how that works and use that chemical knowledge to be able to design better ways to carry out that conversion.
So with catalysis, we really want to improve that efficiency and have less dependence on our natural resources.
That's right. Quantum chemistry is the area of computational chemistry that tries to understand how molecules react with one another, what their energies are, and how atoms move around in a chemical reaction. The problem is the level of accuracy we would need to design a new catalyst is something that even the largest computers today are struggling to realize.
Like those behind us.
Like the ones behind us. The excitement around quantum computing is that rather than waiting for a computer that's 1 billion times more powerful than the one behind us, quantum computing could help us get to that accuracy sooner. And with finite resources, working hand in hand with the classical computing techniques that we already have and use every day.
Putting it simply, nature speaks the language of quantum mechanics, and we're now striving to build computers that can do the same. When our technology is built on the same foundational principles as nature, we'll be able to mimic its behavior and harness that power to make an impact on the world around us. Here's an example. Over 100 years ago, the process that allows us to industrially convert nitrogen to ammonia was developed. This process has been critical to artificial fertilizer production, and in turn, has enabled us to produce enough food for a global population of 7 billion. But the process is incredibly resource intensive, consuming large amounts of our world's precious resources, like natural gas. We want to improve this process for the sake of our environment. To explore this chemical behavior in depth, I'm speaking with Bojana Janowska, a computational chemist here at PNNL, about her work with nitrogenase, an enzyme present in healthy soils.
So I have been a computational chemist for quite a few years here at PNNL. My work focuses mostly on studying biological systems, that's enzymes, to study chemical reactions that are relevant to energy applications. One of the enzymes we're studying is nitrogenase. Fertilizers, and specifically ammonia that's used in fertilizers, is a very energy-intensive reaction. It actually uses about 1% of all the energy produced in the world just to convert nitrogen to ammonia. The bacteria that have this enzyme nitrogenase are able to really interconvert this reaction a lot more efficiently under very mild conditions. Nitrogen is very abundant. It's all around us. So we'd love to be able to take that nitrogen, turn it into ammonia, and have our agriculture really feed the world in a way that doesn't really deplete our energy resources. Nature does it best. We've known that for quite some time, and we're trying really hard to understand all the mechanistic details so that we can build whatever it is that we need to put it into a technology.
That's a great phrase to build on, right? With quantum computing, I think we have the opportunity to now compute closer to how nature computes.
Exactly. We have made a lot of progress using classical computers, but we are constantly hitting against the limitations. Having the power of quantum computing would help us move this field very, very far ahead.
We have deep expertise in computational chemistry. What we don't have is the ability to understand how to put that onto a future quantum computing platform. And so it's been a great partnership. We've been able to use the tools, the languages that are coming out of Microsoft to turn these quantum chemistry capabilities into something that we hope will execute on the next generation of computers.
Yeah, it's great to bring together experts from both sides. And these quantum algorithms can actually have impact and change solutions. That's pretty exciting. It's through these cross-industry partnerships that we're truly able to explore the full impact quantum computing can have on our world. Together with PNNL, we're working to develop quantum algorithms to enable better solutions to challenging problems in chemistry. And these quantum algorithms will one day run on a fully scaled quantum computer. When we join together to share knowledge across disciplines, we have an opportunity to revolutionize fields and unlock amazing capabilities to help save our planet. Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now.
This is Quantum Impact, a brand new series all about quantum computing.
Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now. These solutions will help nurture our planet and improve our lives for generations to come. I'm Dr. Krista Sabori, General Manager of Quantum Systems and Software at Microsoft.
And I'm Dr. Julie Love, Senior Director of Quantum Business Development. Krista and I will be your ambassadors to the world of quantum, where the field is today, what the future holds, and how people are using quantum solutions to address some of the world's toughest challenges. This is Quantum Impact.
In this series, Julie and I will be speaking with researchers, educators, students, and industry leaders from various fields to learn how they are already seeing a difference with quantum solutions. But first, let's unpack quantum computing.
Quantum computing applies the properties of quantum physics to the processing of information. A quantum computer is built with quantum bits, or qubits, whereas a bit in a classical computer holds a binary value of 0 or 1. A qubit can hold a combination of both values. When we use more bits in a classical computer, the compute power grows linearly with the number of bits. With qubits, every time we add a qubit to the quantum computer, the amount of information we can compute with doubles, and so the processing power grows exponentially. We use the wave-like nature of quantum particles to compute in superposition, processing multiple values simultaneously and taking advantage of quantum interference. By deepening our understanding of how quantum computers solve intractable problems, we've made breakthroughs that enable quantum solutions to run on classical hardware, yielding immediate advantages. And what's exciting is that those solutions will be even faster when run on full-scale quantum computers.
This exponentially faster and more powerful computing will accelerate the development of new sustainable materials, improved healthcare, methods to address food production, and combat climate change.
At Microsoft Quantum, we are building the quantum future and empowering people, developers, and organizations to experience quantum impact today.
Together with a global quantum community, we're building a scalable quantum system and ecosystem. We're designing a revolutionary topological qubit. We've made breakthroughs in cryogenic engineering, open sourced our quantum development kit and programming language Q#, and we've introduced a full stack open cloud ecosystem with Azure Quantum, bringing forward quantum solutions, software, and hardware for everyone to learn, build, and solve with quantum today.
These advances are bringing the promise of quantum to our world right now, and we're seeing the results take shape.
Join us as we tackle big issues in chemistry, healthcare, environmental science, and education, uncovering how quantum is being used today and will be used tomorrow to change our world.
Environmental challenges today represent one of our most existential challenges yet.
Land use optimization is this problem that classical computing isn't perfectly poised to solve.
For many of us, quantum computing seems like a relatively new concept. But the reality is that quantum computing has existed for billions of years. Nature is our most powerful quantum computer. At its core, nature operates on a quantum scale and behaves according to the rules of quantum mechanics, a system that governs our world. With quantum computing, we are now harnessing this behavior of the natural world to unlock better environmental solutions to help secure our future. I'm Julie Love, Senior Director of Quantum Business Development at Microsoft. And today, I'm meeting with Lucas Joppa, Microsoft's Chief Environmental Officer, to talk about the complex environmental challenges we're facing today.
We are at the beautiful Oxbow Farms. I thought this would be a super contextual spot for us to talk a little bit about the intersection of environmental challenges and computing.
I've been really excited about our partnership. We have this shared passion for the environment. How can we deploy quantum technologies to help with climate change? What are the issues that you see the world facing?
Environmental challenges today represent, as a human society, one of our most existential challenges yet. We somehow have to figure out how to mitigate and adapt to changing climates, ensure resilient water supplies, somehow sustainably feed a human population growing to 10 billion people, all while stemming an ongoing and catastrophic loss of biodiversity. And we can't do any of those things independently. They have to be done together.
Well, those four big pillars also are in conflict with each other as well. And you've had a lot of work going on in land use optimization, where we can deploy these quantum techniques to solve this vast array of variables that we need to optimize. And simply having local optimizations is not going to cut it at the scale of the Earth.
That's right. Earth is a big place, and there's a lot going on. You can break the Earth into every square meter of land and water. And for every place on Earth, there's many different things that we could use that land or water for. We could use it for protection, for growing food, for sequestering carbon from the atmosphere, for putting houses for people to live. It's all about how we can help people make better choices so that we can minimize our impact on the planet, and the planet can maximize its contributions to human society.
If it's done globally, proper land use optimization will allow us to produce enough food for the world's population while still protecting our communities, our water supply, and animal habitats. To solve optimization problems today, we use new quantum solutions deployed on classical hardware. These algorithms sift through a vast number of possibilities to find an optimal outcome. And they can also scale to the quantum computers of tomorrow, harnessing the full power of quantum to solve tougher problems, like the land use challenges here at Oxbow.
Oxbow as a whole is 250 acres. Being situated on such a large amount of land, it's easy to think, maybe I should grow a little bit more and grow a little bit longer in the season. But doing that, we open ourselves up to some of the negative repercussions that can come about from agriculture. Erosion in a flood event, runoff that hinder the salmon that spawn in the river, things like that. Right now, we're growing on 15 acres of land, but we manage 30. We rotate through those 30 acres in a way that allows us to make the money that we need to as a farm, but also contribute to soil health. The whole mission and focus of what we do is to grow organic food, but do it in a way that's low impact on the environment and actually beneficial to the lands on which we're farming.
I think it's amazing is you're considering not only your land and your business, but the environment around us, which is, not always top of mind.
It definitely isn't. But I think it's something that we're becoming more conscious of because of that. As we look at the way we use our land, we try to recognize that the impact we have on that land will impact our community as well.
Decisions that Oxbow is making showcases all of the different land use decisions that people have to make everywhere.
All of it's part of this global system. And literally, we need to do a global optimization of this problem. We have thousands of variables that are highly interacting. This becomes a vastly exponential search space. And with quantum computers, we can explore that space in a really different way that's not possible with classical computers.
What excites me about quantum computing is this ability to exist in many states at once and to explore many different scenarios. It just seems like a perfect computing architecture to combine with what I think to be one of the world's biggest optimization challenges.
Being at Oxbow with Lucas was a great opportunity to see how these complex land use problems are being solved today. Quantum solutions for optimization will play a pivotal role in helping farmers and land managers make more globally informed decisions that will not only contribute to the overall health of our world, but also lead us into a more sustainable future.
For my own students that are, hard at work in the research laboratory, they can see something that is totally contrary to what they've observed before. That was amazing because it's very rare that you learn something as crazy as quantum mechanics and then learn that it could be used for new technologies.
Education is an important foundation for helping advance a new field, especially in science and technology. Major universities will play a key role in developing the next generation of quantum programmers, scientists, engineers, and researchers. A great place to learn about how universities are advancing quantum knowledge is the University of Washington, one of our partners in the Northwest Quantum Nexus and home of the Quantum X Initiative. I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. And today, I'm meeting with Professor Kai-Mei Fu, an experimental physics researcher and professor focusing on advancing quantum technologies. Kai-Mei, thank you for speaking with me today about quantum information science. Would you tell me a little bit about your role here at the University of Washington?
I'm a professor in the physics department and the electrical and computer engineering department. I teach from first year physics all the way to graduate level courses in quantum information, but then I also run a laboratory developing hardware for quantum information science. This is science and technology where you utilize quantum mechanics to achieve a technological or scientific advantage. We generally split it up into 4 categories. One is quantum computing, algorithms that use entanglement, superposition for a computational advantage, communication. By the laws of quantum mechanics, you can't copy a state. And so that means you can have secure communication. Sensing, we can have very, very high precision sensors that exist in quantum mechanical states. And finally, it's simulation. We want to be able to simulate the world around us, but many of the interesting materials that we have quantum mechanical interactions that we can't simulate on a classical computer.
For myself, I remember taking a cryptography seminar. I was a math major as an undergraduate, and when I took that seminar, I learned that there was a model of computation, namely quantum computing, that could break, most of our public key crypto systems today, right? The mainstay of e-commerce today, RSA. I was perplexed, fascinated, and inspired, all at the same time. And I actually then switched into computer science because I wanted to be able to take that model of computation and make it programmable and, enable users to actually program a quantum computer to solve such problems. So it's pretty exciting to see this emerge. And the numbers of jobs getting posted is growing quite rapidly.
LinkedIn said that in the past year and a half, the number of postings in this area has gone up 180% as compared to the prior 3 to 4 years. So significant growth in this area right now.
So you must see more and more students expressing interest in quantum information science.
When I first came here, I would get a few students a year asking to work in my laboratory at the undergraduate level, and now I get several students every week, and my lab can't possibly have that many researchers.
Talking with Professor Fu reinforces that there's a ton of opportunity and diversity of skills required in the field of quantum information sciences. I wanted to hear from some University of Washington students to understand their experiences and research and what inspired them to pursue a career in quantum.
I did double major with math and physics in my undergrad, and then slowly realized that everything I liked about math was actually physics.
My road into quantum information was a little non-linear.
I was just exploring different fields, and I tried a little bit of synthetic biology.
One day I was working on some homework in one of the upstairs study rooms, and a grad student came up and asked if anybody wanted to see something amazing. He'd just gotten his experiment to work looking at fluorescent molecules in live cells. He could actually watch these molecules moving around. It was just an incredible moment of I was seeing something that maybe 50 people had ever seen before, and I joined their lab the next week.
So your research here at the University of Washington, what is it about? What are you focused on?
My research is in discovering whether we can use quantum devices to aid in the calculations relevant for nuclear and particle physics.
I am an ion trapper. So I trap single barium ions and then use them to study quantum mechanics.
Working with nitrogen vacancy defects in diamond. We have these isolated single atom like defects in this diamond, and we use them as a qubits in a quantum computation system. The future quantum computation holds a lot of promise. Quantum communication also, it's the start of something great. So I want to be part of it.
So as a viewer at home, what's your recommendation to really start learning about this exciting field of quantum information?
Be curious. That's really what I want to say. Be curious. Learn what you can learn now. Learn how, learn about light, how light diffracts through crystals. Do experiments, and of course, have a solid foundation in mathematics. That's probably all you need for entering this field.
I always think back to my own experience. I never took physics until my graduate school days when I jumped straight into quantum mechanics without classical mechanics. So, and there are also opportunities to pick up and start learning quantum programming today, right? With Q# and the Microsoft Quantum Development Kit. You can try little exercises in quantum programming and start to actually, be introduced to some of the concepts of quantum mechanics in a way that may be more familiar to one that, codes daily, right?
Yeah, and you can even have access to quantum simulators and quantum computers through the cloud right now that are publicly accessible that people can play on, which is something that just didn't exist 5 years ago.
Well, thank you so much, Kaimei, for speaking with me today about this really exciting field.
Well, it was my pleasure to be here.
The University of Washington is focusing on educating students to be able to jump into the quantum information sciences. And programs are popping up at universities around the world, full of students ready to push the field forward. It's through these curious and dedicated students that the next breakthroughs and innovations in quantum will come. And I, for one, can't wait to see what they accomplish. Chemistry. It helps make up our world, and yet there are still huge gaps in our understanding of it.
Converting chemicals from one form to another requires very accurate calculations. We see catalysis as one of the killer apps for quantum computing.
What solutions could we develop if we were able to model more complex molecules and reactions on a scalable quantum computer?
Converting chemicals from one form to another, understanding that requires very high level, very accurate calculations so you can make predictions about how the chemical reactions will work. We see catalysis as one of the killer apps for quantum computing.
Chemistry. It helps make up our world, and yet there are still huge gaps in our understanding of it. Our most powerful classical computers are limited in the chemical modeling they can perform, and in turn, the solutions they can unlock. What solutions could we develop, for example, to address sustainability if we were able to model more complex molecules and reactions efficiently? And what if we are able to do that on a scalable quantum computer? I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. Today, I'm traveling to Richland, Washington to meet with Nathan Baker at Pacific Northwest National Laboratory, where we've been partnering to bring the power of quantum to our understanding of chemistry.
Pacific Northwest National Lab, or PNNL as we call it, is a Department of Energy national lab. These laboratories handle large, complex problems of national interest. First and foremost, PNNL is interested in some of the deep problems associated with chemistry. We've been very focused on problems in catalysis. So that is converting chemicals from one form to another. The science of catalysis is trying to understand how that works and use that chemical knowledge to be able to design better ways to carry out that conversion.
So with catalysis, we really want to improve that efficiency and have less dependence on our natural resources.
That's right. Quantum chemistry is the area of computational chemistry that tries to understand how molecules react with one another, what their energies are, and how atoms move around in a chemical reaction. The problem is the level of accuracy we would need to design a new catalyst is something that even the largest computers today are struggling to realize.
Like those behind us.
Like the ones behind us. The excitement around quantum computing is that rather than waiting for a computer that's 1 billion times more powerful than the one behind us, quantum computing could help us get to that accuracy sooner. And with finite resources, working hand in hand with the classical computing techniques that we already have and use every day.
Putting it simply, nature speaks the language of quantum mechanics, and we're now striving to build computers that can do the same. When our technology is built on the same foundational principles as nature, we'll be able to mimic its behavior and harness that power to make an impact on the world around us. Here's an example. Over 100 years ago, the process that allows us to industrially convert nitrogen to ammonia was developed. This process has been critical to artificial fertilizer production, and in turn, has enabled us to produce enough food for a global population of 7 billion. But the process is incredibly resource intensive, consuming large amounts of our world's precious resources, like natural gas. We want to improve this process for the sake of our environment. To explore this chemical behavior in depth, I'm speaking with Bojana Janowska, a computational chemist here at PNNL about her work with nitrogenase, an enzyme present in healthy soils.
So I have been a computational chemist for quite a few years here at PNNL. My work focuses mostly on studying biological systems, that's enzymes, to study chemical reactions that are relevant to energy applications. One of the enzymes we're studying is nitrogenase. Fertilizers, and specifically ammonia that's used in fertilizers, is a very energy intensive reaction. It actually uses about 1% of all the energy produced in the world just to convert nitrogen to ammonia. The bacteria that have this enzyme nitrogenase are able to really interconvert this reaction a lot more efficiently under very mild conditions. Nitrogen is very abundant. It's all around us. So we'd love to be able to take that nitrogen, turn it into ammonia, and have our agriculture really feed the world in a way that doesn't really deplete our energy resources. Nature does it best. We've known that for quite some time, and we're trying really hard to understand all the mechanistic details so that we can build whatever it is that we need to put it into a technology.
That's a great phrase to build on, right? With quantum computing, I think we have the opportunity to now compute closer to how nature computes.
Exactly. We have made a lot of progress using classical computers, but we are constantly hitting against the limitations. Having the power of quantum computing would help us move this field very, very far ahead.
We have deep expertise in computational chemistry. What we don't have is the ability to understand how to put that onto a future quantum computing platform. And so it's been a great partnership. We've been able to use the tools, the languages that are coming out of Microsoft to turn these quantum chemistry capabilities into something that we hope will execute on the next generation of computers.
Yeah, it's great to bring together experts from both sides. These quantum algorithms can actually have impact and change solutions. That's pretty exciting. It's through these cross-industry partnerships that we're truly able to explore the full impact quantum computing can have on our world. Together with PNNL, we're working to develop quantum algorithms to enable better solutions to challenging problems in chemistry. And these quantum algorithms will one day run on a fully scaled quantum computer. When we join together to share knowledge across disciplines, we have an opportunity to revolutionize fields and unlock amazing capabilities to help save our planet. Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now.
This is Quantum Impact, a brand new series all about quantum computing.
Our quantum future is here. Quantum solutions are delivering astonishing innovation and having an impact right now. These solutions will help nurture our planet and improve our lives for generations to come. I'm Dr. Krista Sabori, General Manager of Quantum Systems and Software at Microsoft.
And I'm Dr. Julie Love, Senior Director of Quantum Business Development. Krista and I will be your ambassadors to the world of quantum, where the field is today, what the future holds, and how people are using quantum solutions to address some of the world's toughest challenges. This is Quantum Impact.
In this series, Julie and I will be speaking with researchers, educators, students, and industry leaders from various fields to learn how they are already seeing a difference with quantum solutions. But first, let's unpack quantum computing.
Quantum computing applies the properties of quantum physics to the processing of information. A quantum computer is built with quantum bits, or qubits, whereas a bit in a classical computer holds a binary value of 0 or 1. A qubit can hold a combination of both values. When we use more bits in a classical computer, the compute power grows linearly with the number of bits. With qubits, every time we add a qubit to the quantum computer, the amount of information we can compute with doubles, and so the processing power grows exponentially. We use the wave-like nature of quantum particles to compute in superposition, processing multiple values simultaneously and taking advantage of quantum interference. By deepening our understanding of how quantum computers solve intractable problems, we've made breakthroughs that enable quantum solutions to run on classical hardware, yielding immediate advantages. And what's exciting is that those solutions will be even faster when run on full-scale quantum computers.
This exponentially faster and more powerful computing will accelerate the development of new sustainable materials, improved healthcare, methods to address food production, and combat climate change.
At Microsoft Quantum, we are building the quantum future and empowering people, developers, and organizations to experience quantum impact today.
Together with a global quantum community, we're building a scalable quantum system and ecosystem. We're designing a revolutionary topological qubit. We've made breakthroughs in cryogenic engineering, open sourced our quantum development kit and programming language Q#, and we've introduced a full stack open cloud ecosystem with Azure Quantum, bringing forward quantum solutions, software, and hardware for everyone to learn, build, and solve with quantum today.
These advances are bringing the promise of quantum to our world right now, and we're seeing the results take shape.
Join us as we tackle big issues in chemistry, healthcare, environmental science, and education, uncovering how quantum is being used today and will be used tomorrow to change our world.
Environmental challenges today represent one of our most existential challenges yet.
Land use optimization is this problem that classical computing isn't perfectly poised to solve.
For many of us, quantum computing seems like a relatively new concept. But the reality is that quantum computing has existed for billions of years. Nature is our most powerful quantum computer. At its core, nature operates on a quantum scale and behaves according to the rules of quantum mechanics, a system that governs our world. With quantum computing, we are now harnessing this behavior of the natural world to unlock better environmental solutions to help secure our future. I'm Julie Love, Senior Director of Quantum Business Development at Microsoft. And today, I'm meeting with Lucas Joppa, Microsoft's Chief Environmental Officer, to talk about the complex environmental challenges we're facing today.
We are at the beautiful Oxbow Farms. I thought this would be a super contextual spot for us to talk a little bit about the intersection of environmental challenges and computing.
I've been really excited about our partnership. We have this shared passion for the environment. How can we deploy quantum technologies to help with climate change? What are the issues that you see the world facing?
Environmental challenges today represent, as a human society, one of our most existential challenges yet. We somehow have to figure out how to mitigate and adapt to changing climates, ensure resilient water supplies, somehow sustainably feed a human population growing to 10 billion people, all while stemming an ongoing and catastrophic loss of biodiversity. And we can't do any of those things independently. They have to be done together.
Well, those four big pillars also are in conflict with each other as well. And you had a lot of work going on in land use optimization where we can deploy these quantum techniques to solve this vast array of variables that we need to optimize. And simply having local optimizations is not going to cut it at the scale of the Earth.
That's right. Earth is a big place and there's a lot going on. You can break the Earth into every square meter of land and water. And for every place on Earth, there's many different things that we could use that land or water for. We could use it for protection, for growing food, for sequestering carbon from the atmosphere, for putting houses for people to live. It's all about how we can help people make better choices so that we can minimize our impact on the planet and the planet can maximize its contributions to human society.
If it's done globally, proper land use optimization will allow us to produce enough food for the world's population while still protecting our communities, our water supply, and animal habitats. To solve optimization problems today, we use new quantum solutions deployed on classical hardware. These algorithms sift through a vast number of possibilities to find an optimal outcome. And they can also scale to the quantum computers of tomorrow, harnessing the full power of quantum to solve tougher problems, like the land use challenges here at Oxbow.
Some of them aren't quite ready.
Oxbow as a whole is 250 acres. Being situated on such a large amount of land, it's easy to think, maybe I should grow a little bit more and grow a little bit longer in the season. But doing that, we open ourselves up to some of the negative repercussions that can come about from agriculture. Erosion in a flood event, runoff that hinder the salmon that spawn in the river, things like that. Right now we're growing on 15 acres of land, but we manage 30. We rotate through those 30 acres in a way that allows us to make the money that we need to as a farm, but also contribute to soil health. The whole mission and focus of what we do is to grow organic food, but do it in a way that's low impact on the environment and actually beneficial to the lands on which we're farming.
I think it's amazing as you're considering not only your land and your business, but the environment around us, which is not always top of mind.
It definitely isn't. But I think it's something that we're becoming more conscious of because of that. As we look at the way we use our land, we try to recognize that the impact we have on that land will impact our community as well.
Decisions that Oxbow is making showcases all of the different land use decisions that people have to make everywhere.
All of it's part of this global system. And literally, we need to do a global optimization of this problem. We have thousands of variables that are highly interacting. This becomes a vastly exponential search space. And with quantum computers, we can explore that space in a really different way that's not possible with classical computers.
What excites me about quantum computing is this ability to exist in many states at once and to explore many different scenarios. It just seems like a perfect computing architecture to combine with what I think to be one of the world's biggest optimization challenges.
Being at Oxbow with Lucas was a great opportunity to see how these complex land use problems are being solved today. Quantum solutions for optimization will play a pivotal role in helping farmers and land managers make more globally informed decisions that will not only contribute to the overall health of our world, but also lead us into a more sustainable future.
For my own students that are, hard at work in the research laboratory, they can see something that is totally contrary to what they've observed before. That was amazing because it's very rare that you learn something as crazy as quantum mechanics and then learn that it could be used for new technologies.
Education is an important foundation for helping advance a new field, especially in science and technology. Major universities will play a key role in developing the next generation of quantum programmers, scientists, engineers, and researchers. A great place to learn about how universities are advancing quantum knowledge is the University of Washington, one of our partners in the Northwest Quantum Nexus and home of the Quantum X initiative. I'm Krista Savori, General Manager of Quantum Systems and Software at Microsoft. And today, I'm meeting with Professor Kai-Mei Fu, an experimental physics researcher and professor focusing on advancing quantum technologies. Kai-Mei, thank you for speaking with me today about quantum information science. Would you tell me a little bit about your role here at the University of Washington?
I'm a professor in the physics department and the electrical and computer engineering department. I